we want to commence with the activities of the day. So here is Paul Matchbag, Associate Professor, Dean of our faculty, and then he's here to welcome you.
Thank you. Hi, good morning, and thanks for coming. It's a real privilege to see you all here today, and it's generally very, very exciting for me to be stood here as the Dean of a faculty. The faculty is the Faculty of Business, Law and Digital Technologies, and a huge and important part of the digital technologies obviously is our Computing and Technology Department, of which this is a key member. And in that Department of Computing and Technology, we have this growing, fantastic area of AI and data science, which it's only been here for a couple of years, but it is growing exponentially with huge numbers of interest around the world and a growing student population. You don't need me. I'm only going to be 1 minute this morning to say hello, to tell you about the importance of AI and data science in the future of the world. And I'm particularly looking forward to hearing more about it today. Already had a quick glance at some of the student work today, and it is quite humbling. There's some amazing projects out there. So for those of you that have done that, thank you very much. And Femi's going to take you through the itinerary today, and also the safety, checks as well. But we've got two fantastic speakers today. We've got the two Alexanders, Alexander Gegel from Portsmouth University and the entrepreneur Alexander Barter. Really excited about hearing those talks as well. We want to start a community, an AI community, AI and data science community. And it starts with partnerships. And we want to build those partnerships. So please feel part of that community and keep in contact and help what is going to be one of the most important revolutions, or it already is one of the most important revolutions, in technology for the city, the country, the planet. So, hope you all have a fantastic day. And I've got a few words to say at the end of the day, but you're very welcome. Thank you. There needs to be fire safety and all that.
Yeah, it's right. Thanks. So that's a welcome address from our Dean. Obviously, at one point, I'll need to introduce some of the major participants and the people behind our department and faculty that is making everything to work the way it is. So today is State Conference, obviously. That's Solent Computing, AI and Data Science Conference. It's the first one, and we plan to have a biannual conference. So it will mean all our students are going to have to present their work at international standard. If you are graduating an NSC course in Solent, you will be producing an international standard project, which will be presented at this conference. So this is the first one, and then we will be having subsequent ones, hopefully February and September, hopefully. So I am welcoming you all. This is the inaugural one. As mentioned, it will be biannual. The purpose of the conference is to bring together academics, industry experts, and students to kind of unravel the future with computing technology, and particularly AI. And as Dean mentioned the other time, we are starting the AI community, which you are the pioneer member. So obviously, we will continue to do this, and we will unravel the world together with AI. So we need to kind of demonstrate excellence through the project that will constitute societal impact. And the Dean has testified today. We have got fantastic projects. I supervise some of the projects, and I'm quite amazed with what you have produced. So I'm quite impressed with you guys, and then hopefully we will have to do more in future. So housekeeping, there is fire exit. Obviously, you've got that there. If you see any green stuff, fire exit there and there. We haven't got any plan for any fire alarm or anything, so fire alarm test or anything. So if there is any alarm coming up, then it means we need to all vacate the building. If you need any form of assistance, we have a conference committee who are working around. You already see their tag. There will be conference committee, so you want to speak to them to kind of ask for any form of assistance, irrespective of what you need. So that will be things like if you need to go to the toilet is out there. If you need any information about the event and you're not clear about it, just try and get any of them. But the most important, obviously, is the fire and safety one. Photography, so as you all see, this event is being covered and it means it's being streamed. I would expect anyone that does not want to appear, because some of this can be used for a promotional event. So if you don't want to, you need to speak to the photographers. But this is live event and it's being covered. If you need Wi-Fi, obviously, the Wi-Fi will come on automatically on your computer or any of your device. It will be Solent guest, and you should be able to log into it. Contemplation room, if you think you've got too much and you want to quickly contemplate or have a bit of break, we have the pod, which is in floor 3 of this building. You can always go there and just contemplate for a few minutes and then perhaps come back. But hopefully, we've got so many interesting things that we want you to be part of throughout the day. So, for this conference, we are going to have every of our students presenting their poster. This is going to be the Viva for the MSc project. So we've gone beyond in Solent computing. We're not just doing projects. You are going to do your project, which has society impact, and then you will need to be able to present it to the outside world. So any of these guys will come to you and come and have a look, and you want to talk them through their project. We are going to have some employers come in at a later time. They will also come in and have a look at your project, and they might want to get some of your knowledge. So at the end of the day, every graduate has to do their Viva via a poster presentation. Of this poster presentation, we have 5 selected projects. It was so difficult for us, the team, to pick the best 5. We couldn't, but we have to struggle. So it means we have fantastic projects. So the best 5 of you guys, of the about 72 projects, have been selected, and I've got them to present their work. So Cherries, Georgette Graham, Michael Lowe, Shannon Stevens, Dennis Tineje, and Helen Flew has been chosen to present their projects, and you all will be able to grade and see how impactful these projects are to our growing community as well as the immediate community and society. So all of you are presenting your poster. I've said that. There will be networking and lunch, so we'll be having our lunch. I will want us to try and adhere to time. So we have our lunch, and that will lead to poster presentation, so you can network, meet people, discuss, and have a chat about the future. And if you've got any concern or any questions, feel free to ask. And like I said, we will have a bit of employers coming in, and they might be walking down to your poster stand to ask you questions about your stuff. These 5 gentle ladies and man will be graded again, double grading, and then we will have prizes for the best overall project, and we would have prize for the second and the third as well. All of them will be getting certificates as well, so we'll have certificates for best project, and all of you that are presenting will have your certificate as well. So all this will have to be things that we need to talk about. I'll still come back to let you know more about this, but the happy hour, we've got the conference committee. They've organized a happy hour, so we don't just leave after showing this fantastic work and going through this rigorous exercise. Feel free to go with them to the above bar. That's Grumpy Monkey, and I think they've forced me to get some money off me. I think you're going to be getting free drinks, first 20 that arrive or something like that. So you all should kind of participate and enjoy your day at the end of it. So I've said it earlier, this event is to be shared. So you've got that. The tweets will start going around. So I'll say if you want to join the Twitter straight away and then start to retweet and share the link with people around the world, your loved ones around the world, share it with them and let them know that you're doing, or you are part of this great thing that is actually happening here right now. So we've got the link there, and that will be tweeted around, like I did say. So just join the community. We're building that community. The Twitter link is there. And then we'll be having a feedback session at the end of the day. So I will come back for that. So you should all have the conference proceeding and program events, program of events. So please and please, guys, make use of it, and we will keep you posted or keep you updated on all the activities that are needed to be going on. So that's me just trying to get you all in the loop of what's happening today and how your day is to be spent. And like I said, we have the conference committees around helping as much as possible. They've done fantastic work putting this together. So if you've got any questions whatsoever, feel free to give us a shout. So as you might know, as you've got on the program, what I'll be doing next is to bring in our first keynote. Like I mentioned earlier, if you remember, we are having keynote speakers. And then these speakers, we've got Professor Alexander Giga from University of Portsmouth. He will be giving us a very interesting lecture about AI and the future. And then we have Alex Barter, a founder and entrepreneur of B40 Group as well. He will be talking about AI, IoT, and what the future, where is the money, and kind of a thing. So you need to gain so much from these guys. And then we've got a teaser session from one of ours as well, which is Dr. Andy Fanel. And he will be talking about cybersecurity, more like climate change. You can see how interesting these topics are. I'm sure you don't want to leave the room, and you want to get so much of these people, experienced people. And we will want to get from you as well, based on your poster presentations and whatever work you've done. So we'll try and stick to time. We're running late already, so we want to stick to time. So the first thing I'm going to do right now is to invite our first guest lecturer, keynote speaker, Professor Alexander Giga, and that's from University of Portsmouth. He has got 30 minutes to present, and then you will be able to ask him questions as well. So please welcome our guest, please.
Good morning, everyone, and welcome to this great conference, and I hope you enjoy it. I'd like to thank the organizers first for inviting me to give this lecture. I'm from the School of Computing, the Faculty of Technology at the University of Portsmouth, which is not too far away from here, and today I'll be talking about artificial intelligence, recent developments, and future perspectives. I have to say that this presentation will have a lot of breadth, but not too much depth because I don't have too much time. I'll try to do it within 20 minutes and leave about 10 minutes for questions and discussion. But the aims of these presentations are to introduce basic concepts, approaches, and techniques in AI. I'll be using this acronym throughout the presentation, to highlight benchmark examples, case studies, and application areas for AI, to discuss new developments, future potential, and main challenges for AI, and to facilitate general understanding of AI and its use. Let me start with a definition for natural intelligence, and this ability to perceive or infer information and retain it as knowledge by means of logic, understanding, self-awareness, learning, reasoning, planning, creativity, critical thinking, and/or problem solving. And I'll give a very brief definition of artificial intelligence as well, which is the ability of machines to demonstrate aspects of intelligence as the ones above. I just want to make a note that depending on the number of natural intelligence aspects which are implemented in a particular machine and the extent to which they're implemented, we may distinguish between different types of AI. It could be more basic or more advanced. But sometimes it depends on how you understand natural intelligence aspects as to whether you think that there is AI in a particular system or not. And many academic communities are still arguing about the boundaries of AI. What is human intelligence? It's the ability to learn from experience, adapt to changes, grasp concepts, and apply knowledge. And human intelligence has been the main inspiration source and role model for AI. Because human intelligence is considered to be the most sophisticated type of natural intelligence. And I would like to highlight three also computational intelligence, a term that you may not have come across before, but which I believe is very important. Computational intelligence is a term that combines what we mean by approaches for implementing human intelligence in AI. And it's been the main driving force behind current success of artificial intelligence. Because these days I can't imagine any AI which is not implemented on a computer program, as a computer algorithm, on a computational platform. So the three main strands of computational intelligence are fuzzy systems, which are very good for reasoning and inference, neural networks, which are capable of learning adaptation, and evolutionary algorithms, which are very good for search and optimization. And just to say a few words about AI in the community, and generally speaking, some of you may have come across software tools, environments like MATLAB, Python and R that have specialized toolboxes for the implementation of different types of AI and machine learning algorithms, but also some major companies like Amazon, Google, and IBM and others have their tools which are freely accessible for anyone who'd like to experience what AI is and wants to use AI in their everyday work or other activities. I'd like to mention a few top journals in the area of AI, which are all published by the IEEE Computational Intelligence Society, and these in particular pattern analysis and machine intelligence, fuzzy systems, transactions, they're all transactions, neural networks and learning systems, and evolutionary computation. And all these journals, they have an impact factor which is over 10, which is a very high impact factor for journals in the area of computing. Also, I'd like to mention two fairly big events, which are big not only in terms of the number of participants, but also in terms of their ranking and their high profile, and these in particular, the IEEE Symposium Series in Computational Intelligence, SSCI, and the IEEE World Congress in Computational Intelligence, WCCI. This was the first part of my presentation, which was more general. Now I'll move on to the second one, which will go into a little bit more detail, and I will look at some related topics such as cybernetics and complex systems, big data, machine learning, deep learning and deep models, and then I'll discuss very briefly things like performance evaluation, application areas and case studies, current limitations, possible improvements and main challenges, recent results and research collaborators, and finally I'll mention some authors, research monographs, edited books, and some popular textbooks. AI is not existing in vacuum. There is, overlap with other areas of research that have been around for much longer. And one of these areas, and some of these areas actually have helped AI develop more quickly. So I'd like to discuss some of these areas. The first one being cybernetics, which is transdisciplinary approach to explore and regulate systems which complements AI. And from all these bullet points on this slide, you can see different kind of attributes, especially the first two, like learning, adaptation, cognition, connectivity, communication, and emergence are very typical for AI as well. But the other two, last two bullet points, we talk about subsystems, interactions, common goals, feedback loops, control algorithms, and reference trajectories are more specific to the area of cybernetics. So there will be this kind of symbiosis between the two of these, and this is just an example for an aircraft flight control context on this slide, which is very typical of cybernetics with actual speed, reference speed, speed error, and engine power. Another area that has overlap with AI is the area of complex systems, which are usually considered to be regulatory and other systems composed of many interacting components, like what you see on this graph, which represents a network of airports, and with all these kind of links representing services between these airports. And here we can distinguish between quantitative complexity in terms of number and size elements, or qualitative complexity in terms of noise or disturbances. And we can also identify different attributes of complexity like dimensionality, connectivity, uncertainty, and nonlinearity. And quite often, these attributes of complexity could cause problems when we decide to do modeling in terms of efficiency, transparency, accuracy, and feasibility. Cybernetics in complex systems have been used in AI mainly in the context of cyborgs, robots, sensors with different types of processors, but also actuators with different types of controllers. And we can distinguish between two main modes, semi-automated or fully automated, depending on whether there is a human in the loop. Now move on to the next kind of areas, big data and machine learning have become very popular recently. What is big data? Well, growing large data sets that enable AI. I'm sure you may have read somewhere that big data is music to the ears of AI. The more data we have, the better the AI algorithm, assuming that data is reliable. On the other hand, we owe these latest developments in AI and these recent successes to another recent trend in terms of computational power that's been growing. So this wasn't possible maybe about 2 or 3 decades ago. We didn't have so large data sets and we didn't have this computational power. But if we want to, for example, assess the complexity of a particular task we want to solve, again, we can use what some of you may be familiar with, the so-called big O approach to evaluating complexity, whereby we can have different type of complexity ranging from logarithmic, the lowest, to polynomial factorial, which are the highest. And in terms of big data, again, come across these 4 very important attributes: volume, velocity, veracity, and variety, which characterize different aspects such as the quantity and size of the data, the way it's collected and processed, its quality and value, but also its type and nature. And machine learning has become really very popular recently. Some people even tend to use it as a synonym for AI, but it isn't. It is a very important part of AI, but not everything. So by machine learning, we assume that we've got autonomous learning by computers, mainly from big data, and I'll mention just a few main areas within machine learning, main challenges such as supervised and unsupervised learning, also how to choose train and testing data sets, first to train the model and then to evaluate it, testing features for purpose, and also some challenges, for example, in terms of algorithm bias and variance, which could lead to what we know as model underfitting and overfitting to training data. So we need to try to find a trade-off between these two in order to allow the algorithm to generalize from fresh data, and there are different methods trying to do that, like data normalization and algorithm information, which is linked with AI, deep learning, and deep models. It's characterized by multiple human layers and multiple functional composition, as you can see on this picture for this particular neural network. We've got 2 hidden layers, the green and the red one, and we've got 3 kind of functions, the green, the red, and the yellow one in terms of bias. So when we compose these 3 functions, we end up with multiple functional composition. And that's just an illustration of, for example, where deep learning works well, examples in recognition, where it gradually goes into more detail, starting with edge detection and so forth. I have to say that deep learning has been inspired by what's been around and known as deep models. And they've been around for much longer than deep learning. I want to mention something about them as well. And by deep models, we mean enhanced modeling by gradual accumulation of more detailed information. There are 2 main types of multi-layer models, which implement what we call temporal decomposition, and multi-level models which implement spatial decomposition. You can see 2 examples on the left for multi-layer models, and on the right for multi-layer models, and on the right for multi-level models. Where do we apply deep learning, deep models in AI? Again, first we can apply for different tasks like data collection and cleaning, or feature extraction and selection, or structure and parametric identification, or maybe for model refinement and finalization. And now I'd like to discuss very briefly performance evaluation, application areas, and some case studies. In terms of performance evaluation, you may have noticed more recently by reading academic papers that now people are more interested about more performance evaluation indicators, not just accuracy and efficiency, things like feasibility, transparency, stability, robustness, reliability, consistency, and others. And in terms of application areas, again, AI has been very successful for image recognition, segmentation, data clustering aggregation, and also fall detection diagnosis, and to some extent, for decision making and control. Some case studies, for example, using fuzzy system capture uncertainty and intelligence when choosing routes for military convoys and naval ships, or neural networks analyzing flight data from recorders for preventive diagnosis during aircraft flight and maintenance, or evolutionary algorithms exploring combinatorial problems in flight scheduling and aircraft logistics for airlines. So in other words, depending on the type of problem you've got, and you may choose one or other AI technique, and sometimes you may even combine two or three to get the best of both or all worlds. Other case studies, like selection of players for football match and contestants for a singing competition, maybe these will become more popular in the future. Recommendation for investment on stocks markets, or even voting political elections. I don't want to sound political, but I believe that AI had been used for the EU referendum, maybe the outcome could have been different. Current limitations, possible improvements, and main challenges. Current limitations of AI are for sensitivity to data quality, what I mentioned earlier, when there's noisy data. Dependency on computational performance, for example, if we need to implement it on a mobile platform that doesn't have, a good computing performance and capability. The black box context, which doesn't allow us to see what is inside the AI model. And also the reactive observation. AI has been mainly applied for reactive observation of the environment, but not too much for trying to change the environment for the better. And what are the possible improvements? Again, I've listed these in terms of these 4 bullet points, which relate to the bullet points from the previous slide, like data clean interpolation, the data compression reduction, the glass box or white box context, and proactive control. Some main challenges these days for AI, I'll start with interaction between humans and AI, how they interact, how different tasks are allocated, how they cooperate. And I just want to mention a few very important areas that have become very popular over the recent years. For example, interpretable and explainable AI, how to interpret and explain AI models. Also, responsible and trustworthy AI, how to make sure that we trust AI and it takes responsible decisions. Ethical and legal aspects of AI, again, just to make sure it doesn't discriminate on the basis of gender, age, race, and so forth. And I've mentioned here a few things which are really kind of more recent. Artificial reasoning is gradually complementing, learning. So in other words, maybe next years or decades we'll see more of this, whereby we've got machines that do not only learn from data, but can reason on the basis of what they've learned. Artificial wisdom, which is a higher level of AI, and again, which includes not only learning, but also reasoning. And something which may sound like something from the future or from AI movies, artificial consciousness. I still don't know if and when this could be implemented, maybe a long time in the future, but we'll have to wait and see. Just very briefly to mention some of my results. My main research results have been in, research group I'm in fuzzy systems refinement by concepts from evolutionary algorithms and neural networks. in which case we try to improve model efficiency and transparency while maintaining accuracy and feasibility. And I've listed here two main areas of research. It's rule-based compression with some case studies like aircraft landing control and service center management, but also rule-based composition with some case studies like flotation process modeling and retail product costing. I won't bother to discuss these things in detail. These just kind of two slides explain conceptually these two main approaches, rule-based compression for fuzzy systems and rule-based composition in the context of fuzzy networks. And here on this slide, I just want to mention also my research collaborators from UK and other countries, and I'd like to highlight Professor Solent from Solent University, Solent Computing, with whom we've had very successful collaboration over the years. It's there on the front row. And just to show a few kind of authored research monographs published over the years, mainly areas like machine learning, rule-based systems, fuzzy networks, complex systems, fuzzy systems, and so forth. Also, just to show a few edited books, this one was authored by Professor Colin Penev, and I had the pleasure of being the editor of this book or research monograph, and some others published by Springer, Advances in Computation Intelligence Systems. And I'd like to show some popular textbooks written by others on related areas like artificial intelligence, computational intelligence, machine learning, and deep learning. And I'll stop here. I hope there is time left for questions and discussion. Thank you for your attention.
That's a fantastic from our keynote speaker. Has anyone got any questions? Yeah. Can you speak a bit louder, please? Yeah.
I have a quick question. Thank you for the presentation, by the way. So in your presentation, you mentioned that trustworthiness is a current challenge. What advice would you give for what we can do to robots and
Okay, this is a more generic question. I'll try to give my view on that. About AI taking people's jobs. I think there will be other jobs, maybe the green economy, that people can take, because the whole idea is AI takes jobs that are very difficult or hard to do for people. So it shouldn't be viewed as something which is an enemy to people. Just on the opposite, that helps people, and maybe some people will be free to do other kind of activities, hobbies, and other things. Will have more free time. So that's my view. I'm very positive about that. Just people have to retrain themselves to take other jobs that become available. In terms of people maybe being scared of AI, what may happen again, I think AI is not to blame. If there's someone to blame, it is the people who develop AI algorithms, and not the AI algorithms. So we have to make sure that they kind of stick to these kind of principles of responsibility and trustworthiness. And many prestigious organizations like NATO and European Union have already published some kind of policies on how to use and develop AI in a responsible way. So that's my answer to your question.
Got another question?
Yeah, thank you, Alexander, for the presentation. Excellent information there. I noticed that one word was particularly missing from your presentation, and that was risk. Does risk and the assessment of risk play a big part in a big challenge for AI?
Just to clarify, do you mean the risk from AI or using AI to assess risk? Can you clarify your question?
Using AI
To assess risk, yes. Yes, I think that this is an area where we can use AI, and I happen to know something about that. I've been more recently involved in collaboration activity with different organizations within NATO. So we've been working on trying to assess risk during different types of operations and missions undertaken by NATO, which could affect not only military personnel but also the civilian population. And we are trying to explore AI and how it can and help kind of reduce this risk or assess this risk better.
Thank you. Yeah, question from you.
Thank you for your presentation. I just want to know your opinion about effect of AI on cognitive of humans, so our decision making. So there are instances, especially in the learning community. So there are instances where AI is used to assess grades or to assess assessment to assess individuals, their work. So do you think the impact of AI reduces or affects our decision making? So in the sense that if in the US, for example, there was this situation where a student got 100% in their essay, in the sense that the student used AI to actually write a particular essay. And then AI was now used to grade essay. So outrightly, the student, that particular student got a higher grade compared to those that actually use their knowledge to write it. So my question is, do you think AI affects individuals or going forward, will it affect our cognitive and decision making
Future assessment.
Yes.
Yeah, briefly speaking, yes, AI has been used, or will be used for I would say maybe decision support.
Yeah.
Maybe in the future also decision making if it becomes really trustworthy enough. But for the time being, I think in most cases it's only used for decision support. It should be used only for decision support, whereby then humans should make the final decision based on the recommendations given from the AI. But again, I just want to reiterate my answer to one of the previous questions. I mean, it all depends on who develops the AI, and we have to make sure that the AI is unbiased and is ethical and it doesn't discriminate on any grounds. It doesn't favor anyone, disadvantage others, and so forth. So maybe that's my answer to your question. We have to be careful about that, and we need still to inspect, have a human in the loop to make the final decision at this stage.
One final question. We've got about 2 minutes. Yeah.
I saw a traditional regulatory control system.
Yes.
I wanted to find out how is it that AI has actually improved on these systems.
Yes, I understand. Let me just see if I can find it, because I know what you refer to. Yes, it's number one. Yes. Well, there are many ways in which you can somehow incorporate AI. For example, you can use a neural controller or fuzzy controller or neural fuzzy controller, for example. That's one way in the control. Or you can use some kind of intelligent sensors in the process, which process the data and so forth. So just 2 examples. So you can use AI in different aspects of this control, in different places of this control.
Thank you.
Okay, I'll say we want to thank our first keynote speaker. Thank you Okay, so just to carry on, we've got the second keynote, and we've got Alex Barter, who is the founder of Deputy, and he will be giving us another fantastic lecture on AI versus IoT and the value.
Can you hear me? Does this work? Is this doing anything? Okay. Does this make any difference? Can you hear me? All right. Guys, if you lose me at all, just start doing that, and I'll come back to the mic. I've got a tendency to wander around. Listen, you know, thank you very much for having me at this conference. When I was invited, I was thinking, you know, why invite me? You know, last time I tried to do any sort of work on PyTorch, basically put the computer up and threw it through the window. But I guess my role today is, my name's Alex Barter. I'm the founder, leader, the general team maker of B4T. The purpose of our business, we founded in 2016, was to go and solve data problems. And it was solving data problems that weren't necessarily solvable by conventional methods and means. So we had to do a lot of inventing along the way. So we are based in the metropolis of Eastleigh. So Southampton is a small suburb of this metropolis Eastleigh, as it was shot from street maps or something. Now, our business, we've always got a set of vision. And our vision is really around our flagship product, something called Jellyfish. I'll come back to this at the moment. But our vision is to have jellyfish on every home, whatever that is. Okay. Now, when you set up a business, you need to always ask yourself questions. And believe you me, I've come through some bad times, some good times. But every time we need to make a decision, what do you look to? You must look to your principles and why you do something. So I've got a mission. I'm not going to put one of my widgets on every home. But what's my decision process? And my decision process is my 3 C's. It's cash flow, customer, and community. And I'll just come back to those shortly. So, look across here. You know, you guys are sort of on your journey to learn about AI and all the bits that fall between AI, so natural language processing, machine learning, big data science, so you might be interested in IoT. But when you finish your studying and you've got these great masters, and believe you me, I've been looking at Strand D, interesting, I'm liking Strand D in here. What's next? You go work for a big corporate, go and work in the city, get your skills, earn some dollars. You can write your own magical algorithm and watch the patent checks come in from the patent box. That doesn't happen, by the way.
Or some of you might want to, strike out, start a business, raise some money, create some jobs, and so on and so forth. And that was that's the experience I wanted to bring to you guys today. Is that possibility when you finish your studies, you go and start your own business. So I think the tagline to this talk was IoT and AI, like fish and chips. But where's the money? There's some great studies, but where's the money in this data movement, whatever it is? So IoT is more my speciality, so that's Internet of Things, and the subtext to that is going out and finding the data. And within AI, we're more sort of data science, machine learning plays a strong component part of our toolkit in driving the outcomes that help us make money from big data. So, my 3 C's, my reasons, how I make my decisions. So, my C here is my C for customer. It's like, gee, it's my customer problem. Whatever we do as a business, we put the customer's problem at the centre of what we do, and then we marshal our data science, IoT, machine learning skills to go and solve those problems. Now, some things are particularly low-hanging fruit, and what I can tell you is if you've had an idea and you think it's easy, so is somebody else. It's true. Okay? So, on my experience, there's nothing like doing the hard stuff.
playing the long game. When I started the business, I never wanted to build IoT networks. I built 150. I never wanted to, I was thought, well, buy software. I've spent 4 or 5 years of R&D building. Never thought I'd do that. Making devices. I was never planning to make a device. We've made jellyfish, we made man of war, 5 water companies, 2 ports. So do the hard stuff, because believe you me, if you do the hard stuff and you get that right, then you've got a business there. Something I've got to say about customers, and when you approach your future customer, again from my experience, and customers are absolutely paranoid about you running off like a dog with the sausages with their data and doing something with it. Okay. So I'd say with your customers, softly, be respectful. Don't tell them you're going to do this, that, and other with your data. Just ask to lend the toolkit. We delivered 5 projects for water companies this year. Every single one of them said, just give us the data. We don't want you to see it, we just want you to pass through your sensor data and just give it to us. Within 2 weeks, every single customer said to us, what does this mean? And for all of those, we had just decoded the data and put it into a basic format. 2 weeks after that, all of them said, can you do some analysis on this data for us? The reality is, when you go to all of these companies, there is an absolute dearth of skills in data scientists, data analysts. So you guys you're definitely in the right place, but how do you play, your future career move? Do you go and work for these people, or do you make them work for you? Okay, another C, I know it sounds a bit fluffy, but C is for community. Well, hold on, I'm here. I should be running the business, but I'm here because community is important in how we connect with what we need to do in terms of fixing societal problems. I don't have to tell any of you guys, because I've seen in here, we've got some big problems with global warming. We've got big problems with air quality. We've got big problems with emissions, resources, water shortages, drought, blah, blah, blah. Okay? We know this. These problems are all here. They're in Southampton, they're in Portsmouth, they even happen in Eastleigh, believe it or not. Okay? Now, as somebody from Solent, I started my business here with the core aim of making this area a crucible of great IoT tech. The things that I get back from that, as part of my business, is getting to do wonderful things like this. So, over in Portsmouth, a project we did with the port, where we built Internet of Things air quality sensors. We ran data science to go and collect air quality data. I can't remember, about 70, 80 metrics we were generating sort of every couple of seconds. All that data, we managed to go and find things in Portsmouth Port that they never would have found out if they didn't have the data. While everyone's pointing at the ships going, they're the polluters, we found things in the port, we found cranes that were causing more pollution. The data, it means something. But working within communities, we get to do these wonderful things. So with the local port, did some outreach work to talk through environmental concerns and all this sort of stuff with local schools. You see, this is on the side of the M275. Not totally altruistic exercise, because if you look, there's a little arrow, and you can see what I've brilliantly done, and it's seamless, is there's a poster of 4 of my developers from University of Portsmouth, University of Southampton, University of Portsmouth, University of Solent. Okay? So, by connecting with folk like you guys are the guys are going to do power my business and power everybody else's business, powering Solent. And this is how we're going to go and change. And they're going to change these battles that are sort of appearing on every doorstep. Final C is C for cash flow. No business on earth survives without cash flow. You've got three metrics: you've got your balance sheet, cash flow, and your P&L. Cash flow is everybody's lifeblood. In the world of IoT, data science, AI, everybody jumps to doing the data science bit because in a way it's sort of easy. You need a computer, right? Remember, everybody else is doing that. Where'd you get the data from? Okay, and this was doing the hard thing, and this is what moved my company from doing what everybody else does into doing something different. We went out and built data infrastructure, so we built IoT infrastructure, we built sensors that get data out of difficult places, and we wrapped that whole application capability with the infrastructure, the hardware that we needed to deliver it. And cracking that conundrum, it's a hard thing to do, but that's the thing that unlocks your ability to generate cash and move your business, and take your business from the guys who generate the data to play the long game, to wait for your customers' hubris to fall and they say, can you start doing the data analysis for us? And then start moving into making insights and things to drive their business, making you indispensable to other customers. And that then creates your long-tail business. Okay, I'll just finish off on language and how you guys can make decisions in business or whatever you do. And this is my BS filter. It's called could, can, should. Whenever you're discussing with your teams about projects, things you're doing, decisions you want to make, listen to each other's language and always focus on things that you should do, and then prioritize or deprioritize things that you can do, and on the back board you put the things you could do. So language is important. And language helped us in these other four pictures here, the sorts of projects that we really should have done and we did do. These projects are all compelling. So from the bottom left, there's some idiot up the ladder. Okay, this is air quality in ports. We're the first people to do this. Okay, we're challenging air quality, pollutant emissions within ports, which are almost intrinsically within communities, within conurbations. We're the first people to actively challenge this in a proactive, positive, data-based manner. We're doing this in Portsmouth, and this one's Portland. Just move right into the background. This is our sensors man of war. What we're doing here is plugging a gap in digital agronomy. Would you believe it? Here's another job you guys should go for. Agronomists are growers. The average age of a good agronomist is 58. There's one agronomist for every 5 situations vacant. The business that we're working with are going to turn that into one agronomist required for 14 growers who are using data. Right? So this is about food supply for the future. It's about emissions. It's about quality of food. It's about supply. It's about feeding people. We should be doing these things. Just quick round. Just around to the right. Our flagship product, the most boring thing in the world, is something that sits on a water meter. Yet we've cracked a technical problem that's going to help us unlock reducing leakage. So leakage, 25% of the 3,000 million litres of water we produce every day, 25% of that disappears into the ground somewhere. Don't know where, but we're going to go and find it and eliminate it. The consumption of water in this country is about 135 litres per person today. With this technology, we're going to get it down to 100, so we're going to cut down our demand by 30% on the water we produce. Just as an aside, water companies use 3% of our total energy to pump water around. So every time we do something like this, we can move the dial a little bit more, drop the CO2, blah, 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 blah. Okay? These are things that we should do. So I'll pause for questions there. So I'll just thank you for listening. Very kind of you. And let me back to you.
Absolutely fantastic. So you guys are leading here and you know how to then make the money. One of the fantastic things I picked from this lecture, particularly with most of my AI students, is the aspect of data collection. You know how challenging that could be, and you might need to crack an aspect of that. So you are going out there, obviously, to continue to do that. But yeah, let's ask any questions. Questions?
I think I've come to the wrong lecture numbers as expecting as well.
Yeah, we've got one here. Okay, yeah.
So you mentioned that for all the sensors that you built yourself, your company built, you also utilize the network. Is that network built by you also, or you utilize some other network from other company or
it's a good question. Through experience, we had to do it ourselves. We had to go and build the networks, so we built low power networks. The software to manage and marshal the data, I could have bought it. My guys said we should build it, so we built it. And as we built the software, you learn, you get some experiences, and then you start to roll in new toys. You do your own R&D, you go, okay, I found this, I found this, I found this. And then you start to sell that back to your clients.
So as a follow-up question to that, so if you build your own network, I'm assuming that your reach is relatively limited. You're probably expanding that, but it is limited to where your network can reach.
The conundrum is to wrap application and infrastructure. That's the tricky bit. So where IoT networks have found difficulty in generating a business model, they've tried to follow a traditional telco model that doesn't yield the same sort of revenues. So we took a different approach to sort of like build as the customer buys. So that's the trick.
Yeah. One more question, yeah?
Just out of interest, so are you doing these networks like on-prem or are you using the cloud?
Cloud. We use DigitalOcean, we use Kubernetes to orchestrate all of our software. We use a database as a service within DigitalOcean. This is a multi-tenant system, and we build little microservices for each customer. What it means is we've got a single code base that fulfills a number of different horizontals. So we've got horizontal scaling, but importantly, especially for big data and IoT, we need to vertically scale by keeping this in-house, the ability to vertically scale. At this time, we can run hundreds of thousands of devices basically on something as powerful as a laptop. So
Yeah.
What are your thoughts on the direction that the Internet of Things community is going? For example, you have industrial Internet of Things. I just wanted to find out what are your thoughts?
It's a good question. So, I inhabit a little part of the Internet of Things world called low power wide area networks. It's like, yeah. So the area that I have my experience in, let's say, is low power wide area networks. As a technical movement, it's pretty cool. It does some amazing things in enabling us to go and get all sorts of data. The problem with it is it's a lot of infighting, you know what I mean, it's very tribal. So what I see and what I'm experiencing happening in the provision of the technology is a lot of convergence. Seeing companies kind of using lots of different stacks of IoT connectivity. In terms of industrial IoT, it's kind of a marketing term for sensor technology that's really been there for like 50 years. So yeah, I'm a bit skeptical. What's most important, if you look back to my second C, customer problem, the focus has always got to be on the problem. And people's heads are just coming around to this now. You know, for the techies, and this is why we've had so many problems with Internet of Things to start off with, we try and push solutions, and pushing technology. Customers, they just don't know. They've got other things to do, they don't care. Okay? So we've got to think about the problem, and I know whatever IoT solution I use, the technology's never failed me. You know, if I use data science, apart from PyTorch, PyTorch didn't fail me, I failed PyTorch. But I know that there's skills there, there's tools there, so no problem.
Yeah. Hi. Just out of curiosity, when you collect these data from the natural resources like emissions, do you have like a special team to let you find what you are looking for? Like if, for example, if I collect a sample from the sun, I don't know what that is, I don't know who it says it for. You have like a special team to...
We have a brief. What I would say, if you're looking to start a business, you've got to find the need. In large organisations, the needs tend to be driven around things called statutory obligations. So if you have a regulated, if you have to do something through regulation, so for instance with air quality, there are things that you sort of have to do. For instance, levels of particulates. Over a month, Environment Agency through DEFRA says, you know, your particulates that over a month must not go on average over whether it's 40 micrograms per cubic metre, something like that. That is a statutory obligation, so we start with what we've got to go and measure. As we measure these things, the insights come out. And the insights come out when we look at other things that happen at the same time. So with the air quality project we did for Portsmouth Port, the reason that we won that piece of work is we did something contextual to the port. We looked at marine traffic and we built that into our sensor. So the IoT data that we generated was annotated in real time with something called the AIS, which is the Automatic Identification System, marking of each vessel, geofence within the area of the sensor. So we did is to make, you know, a number of different sort of parallel or tangential data sets to drive the insight. So it's a long way of answering. We look for a particular metric, but then we look to the side and we understand the system and the context to understand why that metric changes. You know, sometimes you find things that...
One final question? We've got 5 minutes left. Yeah, carry on. Yeah, yeah.
Oh, okay. So you said you had many challenges in your business. What would you say has been the biggest challenge? Like, for example, the price conference, what would you say has been the biggest challenge, and how have you overcome that? And what's the one secret for like business success if you were to go out and do it?
We've had the sort of challenges that aren't sort of direct business. COVID was a killer because that sort of choked off the ability of our customers to roll projects out. So that gave us a cash flow problem. So what we did when that particular sector kind of closed down is we took the products and capability that we had, and then we pointed it to new sectors. So the work we've done in horticulture, that's the case in point. So where we built the jellyfish sensor to do this, and this in the water sector. When that all contracted, horticulture was still going on. There was no change there. So we drove the products and services into that sector. And as we've come out of COVID, we've now got one product, two sectors, and both are growing. So when you have problems, and believe you me, there are many daily things. You have to turn these things into, you've got to turn your weaknesses and your threats into strengths and opportunities. Another one just off the top of the bat, I lost a big contract. I was nailed on for big contract. The challenge, apart from me jumping out the second-story window, was okay. Well, we haven't got the big thing, but can we get 10% of it? So another challenge is, for yourself, you've got to kind of detach your personality from the business. You've actually got to be two people. You have to be objective when things go wrong, because they go wrong all the time.
Right. A very fantastic talk there. And one of the things I'll pick again is turning challenges to strength. So if you look at it, we face challenges and we don't just give up and say, yeah, that's it. And in here, our AI students have started to work on different things, and we are looking at picking insights. So how weather is going to link with finances, stock and shares. Why is the weather affecting it? Or why is any other thing connected to stock exchange? So these are loads of every other things that AI is going to help us to kind of unravel. We don't know. The insights that's going to come from that. And a lot of this will turn to cash, just like Alex is giving a lecture about it. So thank you so much. So so good morning, isn't it? So two fantastic lectures to kind of open our brain and see what we could do with AI and what we do with computer technology and all that. So now we need to kind of take a bit of time to relax a bit rather than taking in another information. So it is tea break. So if we all want to walk to the atrium and get our tea or coffee, and then we'll be back in the next 20 minutes, hopefully. So let's walk down to the atrium. Coffee, tea. If you listen to where the tea is, the atrium, and then we'll be back in 20 minutes. So expected time 11. Expected back 11. coming back on time. Okay, so as I mentioned, one of the major activities today is we having to get some of our work, the work that's been done in this university, presented to you, and perhaps as this has been streamed across the world, so it means other people might be able to see what we're doing. So we've got 5 selected projects, say 5 selected projects, or from the best project. We have a bit of concern. It was difficult for us to select the best 5 because we have so many outstanding projects. But we managed to come up with 5 of them. So at the end of the day, we will want them to show you some of the things that we've done. It's just a bit of what we are doing here. I'm sure you all know you've done some fantastic projects. We just need to showcase some of them. And then, obviously, after this, we can then go to our various courses and demonstrate to the other people what we might have been doing. So we have got 5 of them: Cherise, Michael, Shani, Denise, and Helen. They will be presenting now. So they've got 15 minutes, 10 minutes to present, and then about 5 minutes for questions. They have all done really well. So feel free to ask them questions, and if you cannot at the plenary, you might be able to get them at a later time to ask them questions about this project. Some of this project will be a continuing thing within the university because we might want to build on some of the project and carry on for future. So the first of the presenters, in no particular order as its moment, is Sherry's Georgette Graham. She has produced something around natural language processing for legal document review, and that's categorizing deontologic modalities in contracts. So I'll just call you guys to join me in welcoming Cherise. If you please come to the...
Of being the first person. Guys, laugh at my joke, I'm nervous. Okay, so my name is Georgette. Like you've seen, my topic is natural language processing for legal document review, categorizing deontologic modalities in contracts. Don't worry, I'm going to explain everything. So for this presentation, I'm going to quickly just give you a background about my project, tell you about the aim, objectives, all that boring stuff, the methodology, the results, and finally, the fun part, the demo. But before I begin, oh my God, what am I doing there? It's not up there, I'm doing it on my computer. There you go. Yes. So my first question to you is, anybody, what percentage of the lawyer's time do you think is spent reviewing contracts? Anyone?
20%.
20%? One more, so twice. Anybody else?
18%.
18 or
80.
18? Ooh, oh. One more? 50. 50. One more?
99.
Well, if you look at this last image, that's essentially what a lawyer does, and it's actually 50%. Half of a lawyer's time is spent buried reviewing contracts, and I can personally attest to that as a lawyer. 9 a.m. to 5 p.m. You probably spend half of that reviewing documents, whether it's like a merger and acquisition deal. You're reviewing contracts with hundreds of pages, and when you're done doing that, you do it again for the second client, the third client, and who pays for all of this? The client. So the client is paying by the hour, and so even though the lawyer is reviewing, and you're getting results, it's taking too much time to get it done. And that's pretty much the basis of my project. How do we cut that 50% down to 18% maybe? 5%? Let's find out. So quick background, like I said, contract is a repetitive process. We just sit and review, and the aim of the contract review is to identify problematic legal sentences. These are known as norms, and norms are expressed using deontologic modalities. essentially a deontic modality is like a permission, obligation, or prohibition. So a permission would be an entitlement. You could say, Femi, you may walk on the grass. So he could choose to walk on the grass, but he doesn't have to. Obligation is a duty. You have to do it. You must pay your taxes. You must walk on the grass. And then prohibition now is like the negation of those two. You must not, you shall not walk on the grass. If you do walk on the grass, even though you're not supposed to, it's a violation, and you're usually supposed to pay a fine or you could go to jail. So that's the basis of deontic modalities. And so when a lawyer reviews the contract, that's essentially what they're looking for and deciding what the legal risk is to the client. Now, with machine learning, we could automate or even semi-automate this process, and so reduce the time spent by the lawyer reviewing the contract, and therefore reduce the cost to the client. You see where I'm going with this, trying to get rid of the jobs for the lawyers. And so the aim of my project essentially is to use machine learning to review contracts by classifying sentences based on deontic labels. And deontic labels, permission, obligation, prohibition, remember that. The objectives, a lot of them, but basically it was pretty much finding the best machine learning model for my task, which is a text classification task, because we're trying to classify the sentences, comparing what's called domain-specific and generic pre-trained word embedding techniques, creating the gold standard corpus, and this was done by manually going through contracts and making the data. And finally, pre-processing all of this and pre-processing, training, and assessing our model using accuracy, precision, and ranking loss. And of course, in the demo, you will see that I designed an interactive interface that just demonstrates what the final thing could be done. Methodology, so like I said before, annotation, data creation. We heard from Alexandra, data. Everybody wants to do data science, but data creation is a very important part of that. Without data, you can't do the other steps in the data life cycle. And so I pretty much had 29 contracts, and I got 6 experienced lawyers and a law student. Thank you so very much to everybody, big up, to help me annotate these contracts. So we went through the contracts sentence for sentence and determined whether or not the contract is a norm or non-norm. And if it's a norm, we decided whether it was permission, obligation, or prohibition. After all of this was done, I then went through all of these annotations, calculated what's called the Cohen's kappa, which pretty much tells you how accurate the annotations were, and then created a final version of the data set, which is the gold standard. And I had 2 data sets, one for the binary task, which is determining if the sentence is norm or non-norm, and then a multi-label task data set, which determines if that sentence is permission, obligation, or prohibition. After all this, I did some EDA, that's exploratory data analysis and preprocessing using Pandas and OTK, stuff like resampling because I had too many obligations compared to permission and prohibition, tokenization to cut those words down, lemmatization, and vectorization, which is very important for natural language processing. It's essentially converting those words to a language that the machine understands, so ones and zeros. Finally, training and testing. I explored with the traditional machine learning models such as logistic regression, support vector machine, and also some neural networks, the convolutional neural network, as well as the CNN with law2vec word embedding. You might have heard of GLOV, FastTech, or Word2vec. This is the law version of that. And then LSTM. And of course, I tested these models using ranking loss, precision, and accuracy. And finally, the results. The annotators, there was substantial to almost perfect agreement amongst the annotators. This means that they properly interpreted my instructions when they were annotating the contracts. And in terms of the model performance, the support vector machine was the best performing traditional model, while the CNN was the best performing model overall for both tasks that I did. I also found that the CNN with law2vec pre-trained word embedding did not improve the results, which might be because, I don't know, data set size is always an issue. And my data set was 1,664 records and 360, so pretty small data set, only 29 contracts annotated. Finally, I can quickly get this done and go back to my seat. So I'm going to show you a demo. I created an application using PyWeb.io And it's just to show you what it could look like, or what this whole application, how this application could be used in an actual complete package for lawyers or clients. So it's called Contract Viz, and it's essentially going to accept a sentence, do some cleaning, and then tell you if the sentence is norm or non-norm, and then what tag it is. So here we go. So here we just have some terms and conditions that you have to accept. To the left is a contract. And I'll pause here to say the first sentence I copied, and it's not pausing. Okay. The first sentence copied and pasted is just a non-norm. It doesn't say you should do something, you must, you shall not. So it should not actually come up as permission, obligation, or prohibition. And there you go, it says, sorry, this thing keeps moving quickly. 1 minute, please. Yeah. It says, sorry, this sentence cannot be classified. And it means that that sentence doesn't say you must, or must, may, or must not do something. Moving on, I'm going to show you where I copied another sentence, which is a norm sentence, and so it will be classified. So to the left is just my going through the contract and copying one of the sentences that would fit. This contract also was not shown to the model or to the program when I was training and testing. And there you go. It says the sentence you provided is this, that's the tag, and there's a disclaimer saying that it's not legal advice. And finally, it's going to show you that the program is capable of doing multi-label classification, which is predicting more than one tag. So if you have a sentence that has a prohibition at the start, and then followed by a permission or an obligation, it should be able to give you both. And I'm showing you right now. There you go. Scroll down, it says obligation and prohibition. And the rest of it is just some fancy stuff, such as telling the user what is a norm, what is a permission, and giving you a link to read more. And finally, I'm out of time. I just want to say thanks to everybody, the Atticus Project, for providing the data. All my annotators, Andreen, Kate Edison May, Odane, Ryan, and Tishana. Thank you so very much, Tish. I love you, love you, love you. And all my colleagues who helped me to do this. And special thanks to Sade for her continuous support. Thank you so very much for listening to my presentation.
Absolutely fantastic. So lawyers, there's something that is coming out there soon. Contact Georgette. He's going to help you with all your contracts. Have we got any questions, guys? Andy?
Yeah, I love the little, this is not legal advice. That was cute.
Always have to put that there.
So you're doing, this is the ontology, very useful for identifying these applications and stuff. How would you like to develop that to incorporate, as you said at the end there, definitions, structural knowledge, identities, and things like that?
So thank you for your question. There are many uses for this application. So it's very basic because it's just identifying what the DLT cleaner is. Potential uses of this would be, firstly, in terms of lawyers using the application, you could further develop it to do some sort of norm conflict identification. So if at the start of the contract you have a norm that says you must walk on the grass, but then later on it says you must not walk on the grass. That's a conflict because which one are you actually supposed to observe? And so if you're able to identify this conflict, it would be really useful to the lawyer. On the side of the client, if a client were to use this for himself, then it would be useful to do a further NLP task, such as text summarization. So it would somehow convert the legal jargon or the legal language to, a language that's understood by the layman. Because lawyers, they love to fluff and put a lot of words that nobody understands. So I think those are two potential uses in the real world.
Fantastic. Just 5 minutes or one more question. Yeah.
Good demonstration and an excellent presentation. Thank you very much. I noticed in your software demonstration that in each assessment there's a line at the bottom, a disclaimer, that said all this information should be checked by a lawyer. Is that somewhat counterproductive by having to do that?
Thank you for the question. Actually, it's not, because the purpose of this is just to show what could actually be done in practice, and it's for my project. So that has to be there so everyone here knows that you can't just text me and use my app and get legal advice. But in terms of scaling this project, of course, if we were to, for instance, the Atticus project who provided the data set, I did speak with them and they were actually excited about it and wanted to do it on a larger scale. So in that case, if we did it larger and made it more accurate, for instance, then definitely we'd be able to remove that disclaimer.
Thank you, Georgette. That was a fantastic presentation, but it's just one of all the presentations we've got here. So the next person to present here now is Michael, and then I will get Michael to come on board.
Hello, thank you everyone for coming. So my name is Michael, and I'm very honoured today to be able to present my project to you guys. So anyone here who drives, can I get a show of hands quickly? So we've got a couple of people that drives in, that's perfect. So you might be looking at that and think, you know, what does that mean? Reinforcement learning for multi-intersection traffic light controls with lane area detection range, okay. So don't worry, I'll explain what each sort of component means as we go through the presentation. So a bit about myself, I actually have a background in health and fitness, so I was a personal trainer before. I studied on this course and I did my bachelor's in Solent as well, which is the fitness and personal training. I actually worked in industry for about 2 or 3 years with all kinds of clients, clinical, also like general population and the sports sort of clients as well. And throughout my time at uni, I also started a PT app business which helped personal trainers manage their clienteles, and that's how I got into software engineering. And today I'm working at a company in Bournemouth, building apps, tech for good. That's stuff to do with like climate, deforestation, and just generally tech for good. And one day I was driving back from work actually and stopped at an intersection, and I'm sure others can relate. I find myself sat there on the red light and there was no traffic around. So that was a problem that got me thinking, and after some research and digging around the data, some of the statistics suggested that there was about 356 billion miles traveled in 2019, so these are pre-pandemic figures. And obviously these cause like congestions in like bigger cities or towns, and the side effects of those would obviously be like emissions of pollutants and reduced productivity. People want to get to work, but they're stuck in traffic. And also road accidents as well. So this could help reduce costs if we could help solve these problems. Now, currently there are research out there that implements AI solutions to solve traffic problems. And these are typically in the form of reinforcement learning. So just a bit about reinforcement learning. It's very common in the sense that it's, for example, this is an analogy. You are training a dog, and you throw the ball, and you're expecting the dog to play fetch. So if the dog returns the ball, you give it a reward. We say that's a reward of 1. If the dog doesn't return the ball, then we say, you don't get a reward for that. That was not the action that I was hoping for, so you get a reward of 0. So essentially, that's the really high-level overview of what reinforcement learning is. There's many different implementations of it. And much of the research used deep Q learning. So a bit about Q learning is, you can see the agent, which is the dog, and the state or the environment. So for instance, if I throw the ball 10 meters down in that direction, and let's say I want to reward the dog if it goes past 5 meters. So that would be one state, so that'll be one condition. And if the dog gets the ball, then that'll get a reward, and then that association would be like a Q value. We call it a Q value. So essentially the model's trying to maximize or pick the best Q value for the action at that given state. And we use neural networks in deep Q learning to predict the Q values or the Q table. and then pick the best action based off that. So that's just like a really high-level overview. But generally, we're looking at the literature, and I was just exploring what's kind of the solutions out there at the moment. I found that there was quite a mix of sort of real-world and fake road networks used. So some authors opted to go for single intersections or artificially created multiple intersections, which doesn't really correspond to how a real road infrastructure would behave. Some use real-world data, but actually assumes global visibility, meaning that the model that they've implemented assumed that they knew where all the vehicles are on the road, which is unrealistic. So my sort of research into this field was to look at adding more constraints to the current literature, adding more constraints to the models, and just limiting the agent in a way so it's more realistic for the real-world application. So in terms of my project, so in order to achieve this, I limited detector ranges of traffic lights, cameras, and these are all in the simulation called Simulation of Urban Mobility. So it's the software I've used to do all the simulation. It's open source, you could use it. And limited it to about 15 to 20 meters in detector range, and actually pulled the OpenStreetMaps data from Baker Street, London, just because I was there one day and I was like, oh, it's quite busy around here, so I thought, have a look at that. And actually look on the data for the statistics. It's about 12,000 daily count of traffic at its peak. And the key metrics that I've used to sort of track the performance was average time loss, waiting time, vehicle count, episode reward. So average time loss was basically how much time was wasted when driving at a slower speeds. Waiting time is the time you wasted stopped at intersections, as well as, so vehicle count was how many vehicles were on the road network at the end of the simulation. The episode rewards was more specific towards the AI used, so basically how well the AI performed. And I used three different variants of neural networks inside the DQN. I'll get into that in a minute. But here's a quick demo. And on the left, you can see I've got no AI solution. So that's just fixed timing, fixed intervals, traffic lights run on an interval, 60 seconds on, 60 seconds off. MLP2, which I'll explain what that is in a minute, is an AI solution. And you see those turquoise lines, they're basically detectors. And you can see that's the traffic light intersections as well. So if I play the video, it's frozen. Ooh. I think I might have to scroll through the video for some reason, so it's not loading. Okay, so I don't think it's going to play. Maybe. Oh, there we go. Yes. Okay, perfect. So you skipped at the start. So as you can see on the left side, it's the no AI solution. You can see it's quite congested at the moment, and it's now crashed. The AI is too powerful, unfortunately, so I decided to take over the presentation. Okay, let's try that again. Okay, cool. So on the left, you can see now it's like building up. And on the right is the AI solution, and it's starting to get a bit more congested now on the left side. So you can see some traffic stopped on the intersections, whilst the right side with the AI is still flowing quite nicely. So this occurs over about 3,600 time steps, which is equivalent to 1 hour. And I ran this for about 50 episodes, so 50 iterations, training the model. And eventually it gets to the point where there's so much traffic on the road, it gets congested on both, but it's still sorting it out on the right side as well. So looking more for a more quantitative way, we can see that. So MLP2, the number, so MLP will be the AI, the 2 or the 0 and 1 denotes the complexity of the model. Starting from 0, which is very basic, single layer. As you get to 2, you have more layers, and this generalizes the information as it flows through the network. And as you can see, MLP2, the more complex network, reduced the time loss and the vehicle count by about 16% for time loss, 11% for vehicle count at the end of the simulation. Interestingly, it didn't perform as well as a basic model in terms of waiting time. So a more simpler model achieved better results, about 19%, but it's still, the more complex model still achieved a reduction compared to the baseline, which is no AI. And as you can see, you've got the table on the bottom right as well for all the other results. And in conclusion, like I said, so improvements compared to not using AI was observed, and less time lost from driving at slower speeds, less time halted at intersections, so more productivity, less stopped means less pollution, and hopefully less road accidents as well. And in my hypothesis, I've also expected that it would not outperform what's out there currently in literature, just because I've added more constraints to the model and more limitations to how data was being used and observed for the agent. Therefore, it didn't perform as well as what's out there currently in terms of research, but it performed better than a baseline model. So thank you guys for listening. So that's my website if you want to connect. Thank you very much.
Absolutely fantastic. I'm sure you all know that more than 7% of people here drive, and we all face this type of problem, sitting by the traffic light and just waiting for no reason. So I think some work is done around AI to see how best we could overcome this problem. Any questions, guys? Questions? Yep.
Hi, Mike. I just wanted to ask, how do you see your project fitting in with like self-driving cars? And is that something you can talk about? Because self-driving cars are sort of meant to be the future.
Yes.
So is your project sort of just relevant to today's cars, or have you thought about self-driving cars and the impact of that whole ecosystem?
Of course, yes. So actually, looking at the research, mine ties in more into the road infrastructure that's currently existing and the sort of like the thing that's already been built. But it's quite interesting to see because there's been some research around smart cities and actually exposing sort of APIs and ways that you could integrate all kinds of data together. So just autonomous vehicles can actually tap into road infrastructure data and sort of algorithms and AI on the edge as well, and to basically optimize the way that it drives or it routes certain like destinations. So it could all tie in through that's what I've seen in the current literature at the moment. So, but yeah, I can see how the AI can be implemented that way as well.
Any other questions? Yep. Pass the mic.
Your sensors, have you compared those to the physical sensors that are already currently in use with road traffic control, such as the magnetic sensors in the road and
Yes, so there's actually quite a different amount of types of sensors available. Some, to my knowledge, are like actuated, and they've got like thermal sensors and everything as well. So at the moment, mine's just comparing just the fixed timing sensors or sort of control systems. They're still common around the road networks, but my research was more looking at adding the limitations to the research that has already implemented the AI in that respect with that road sensor in particular. I guess that could be a limitation and a future design as well, like looking into the future studies. Yeah.
And sorry, did it take into account all traffic or just vehicle traffic?
At the moment, it takes in just cars, but there's the scope actually, and it's quite easy with, but it adds it more complexity with Sumo. Sumo lets you integrate and specify what type of vehicles you like to see on the simulation, such as trucks, pedestrians even. So you could actually have thermal sensors in the simulation, but that just adds more sort of complexity to the network in that sense. And I think still quite a few things that needs to be done around that. But yeah, Sumo does allow that as well. So yeah, perfect.
One more before we go. Any other questions? Yep.
During your research,
Yep.
did you just focus on reinforcement learning, or did you look at computer vision to solve the problem you're trying to solve? Like computer vision actually detecting amount of cars, if they are pedestrians and all that, and the logic behind that. Did you just focus on reinforcement learning, or did you do your research on computer vision too?
So the question is whether I've just focused on basically the sort of the management of the traffic or the detection.
At the beginning, you said you were in the traffic, and that's when you
Perfect, yeah. So I came across both computer vision and reinforcement learning. I've noticed that the reinforcement learning, there's still some work that needs to be done, such as the limitation, adding the limitation to the row sensors to make it more realistic in the simulation, so it's more practical to implement. There's quite a lot around the computer vision at the moment for detecting vehicles, so I thought there's a good body of research there already, and I thought just moving into the reinforcement learning side and actually utilizing the results of the computer vision into the reinforcement learning model to help optimize the road traffic. So that was the idea behind that.
Is it going to be a very quick one yet?
Yeah, Mike,
Yep.
just wanted to ask, in terms of your choice of 50 episodes to train the model, did you come about with that number via the literature review that you conducted, or was it, how did you come up with that specific number?
Yeah, so the literature review, typically about 100, 200 or so, because I was using a simpler model, the MLP, so it actually was much more simpler for me, and the amount of data that I was actually observing, it was just queue lengths of the vehicle, so it wasn't too complex, so I didn't need that many episodes, and it was just through trial and error as well. 50 episodes worked quite well. It started leveling off the results, so it's cut off at the 50 episodes.
Okay, thank you so much.
Thank you very much.
So our next presenter is going to be Shani Stevens, and she will be presenting our topic around chat's British Sign Language. Put it in your pocket.
I didn't have a pocket. Hi, a very good morning. So I'm here to discuss about the British Sign Language Recognition System, and I have labeled it as HandChat. So I'm Shani Stephen, and a student of MSc Applied AI and Data Science. So let me take you through the brief introduction and the background of the project. So what exactly is sign language? It is a visual form of communication used by the hard of hearing community using their hand gestures, lip movement, facial expression, and body posture. So few facts and statistics. So like 200 plus sign languages are there all around the world, as you see in the distribution graph as on the screen. And 41 countries have officially recognized this language, and UK is one among them. 23rd September is celebrated as the International Day of Sign Language, and the theme for this year was Sign Language Unite Us. So let me take you through a few of the statistics. So the British Deaf Association states there are 151,000 individuals who can use British Sign Language, BSL, and out of which 87 users are deaf. And the National Registers for Communication Professionals working with deaf and blind people in 2015 have stated that there are 908 registered interpreters, 234 trainee interpreters, and 11 registered translators. From this, it's very evident that the number of users against the number of interpreters is very less. So that raised the question, can artificial intelligence and machine learning be applied in real-time visual recognition of British Sign Language? So to solve this, I have taken the methods and methodology as you are seeing on the screen. So the proposed architecture is like, we'll load the graphical user interface, which will activate the camera, where the signer can start signing, and the hands will be detected, the coordinates will be captured, and the machine learning process will predict the label of the sign and display on the screen. The stages of implementation was data collection, data cleaning, pre-processing, model selection, evaluation, and the application of the model. So let me take you through these stages very quickly. Data collection, the most difficult and tedious part of the project, because the data I have collected is a primary data through the vision-based acquisition, and the data is collected to two main methods, that is OpenCV and MediaPipe, through the use of Python codes. 120 videos were collected for finger spelling, that is signs A to Z. For each sign, 120 videos were collected, and each video was having 30 frames. And as you see on the screen, this is the MediaPipe hand landmarks, where there are 21 landmark points, and each landmark point will have 3 coordinate values, that is X, Y, and Z. So total of 126 landmark points from both the hands was collected from each frame. So this is how the data was collected, and the NumPy array file shows the 126 coordinate of a sample frame. The method was adopted because it used less space and it's faster for training, easier pre-processing, and privacy preservation, as we are not storing any images of any of the signers. The next stage was the data cleaning. Though we have collected the data, we cannot completely tell the data was clear and had a better quality. In order to improve the quality, first it was a challenge to find out the invalid frames or the invalid videos. As you see on the screen, for the alphabet A, the 90, video number 90 was invalid because the hands were not captured properly. So this was again recaptured, and an algorithm was executed to find out if further any other videos were invalid. After the cleaning of the data, then I moved to the pre-processing stage, where the labels were first converted to numerical using the enumerate function. And as you are seeing, so A to Z is converted to 0 to 25. The next stage was the one-hot coding, where each of its label was converted to a vector form, where 1 will be at the position of its index value. So on the screen you are seeing for 4 examples of A and 4 examples of B. So A being at the position 0, the first 4 values are for A, and the next 4 values are for B. The next was the train, test, and validation split. So the total data which I have collected, I have divided it 80% of train and 20% of test. And out of the train, then 20% was taken for the validation. Next was the selection of the model. Since this is like a series of frames, the 2 suitable models which were found was the long short-term memory, that is LSTM, and gated recurrent unit, GRU, which belongs to the which can solve the problem of having a sequence of frames. And in order to deepen the model, I have stacked few layers, and the activation functions used were ReLU and softmax, and the regularization techniques which was used was early stopping to avoid the overfitting. And during the compilation, the optimizers were ADAM, the metric was categorical accuracy, and categorical cost entropy was used as a loss function. This is because they will give out an output in the one hot code form. Then moving to the evaluation, so the metrics which were used to address the performance was accuracy, confusion metrics, F1 score, recall, and precision. And apart from this, I also did a critical evaluation of a selected model in order to find out how well the system can perform. So these are the results. So the LSTM gave a training accuracy of 95.2, test percentage of 94.2, GRU gave 94.2 for train and a test of 91.5. So it's clear like LSTM performed better than GRU in terms of accuracy. But accuracy alone will not give a complete idea. So I went for the F1 score. The overall F1 score is 90.94 for LSTM, and GRU was 0.91. The graphs are showing like the signs from A to Z for each of the values. You are seeing here on the graph is like 22 class performed well for LSTM, whereas GRU it was just 18. Like 0.9 crossed 22 classes for LSTM. So I took the LSTM as the best model for solving this problem, and the real-time testing gave me an accuracy of 86%. So let me show you a demo of the work. It's like the voice is there.
Is this the wrong one?
And this is the right one, but the voice is not coming in.
So do I take this off the screen? Can you pause your time? Which one do you want?
I need the voice to be on. There is a voice in the.
So like here. At what point?
Can you keep it here? And the voice should be on. Can you speak?
Get them to help you. Hold on, I'll pause your time.
Yeah. voice is not there. No.
Yeah, just show it. The voice is not coming up.
The video is having a problem with the voice.
Oh, yeah, we have no video sound. We can't have video sound. We're not set up for it.
Okay. So let me explain you briefly. So this is the first page of the application. That is a home page which is giving us the details about the details of the application. Like the first page will be finger spelling, signs A to Z. And the second page is for signs apple, tomato, tea, cake, burger, and orange. So let's start with finger spelling. So the camera is activated and I'm start signing. The first sign is for C. And for A, it's E, K, J, which is dynamic in nature. And now I'm moving to the left-hand signs. That's C for left hand. That's P. And that's D. Now let's see a few of the words. That's orange, burger, tomato, cake, that was apple, yeah, apple, then tea, and apple again. So let me conclude by saying like sign language recognition is an active area of research. Computer vision techniques and media pipe solution along with the deep learning model like LSTM has helped me to completely find out a solution for this problem and support the hard of hearing community. The future work is like now I have only considered the hands and few of the words as well as the alphabets. I know like there are more words to be added once the vocabulary is expanded, including the lip movement, facial expression, and posture. A fully developed BSL recognition system can be used in shopping assistants, drive-thrus, ticket counters, and public transport. So let's make AI a better future for the world. Thank you.
You've got a very normalized camera view there without any occlusion and things like that. Have you kind of played around with more realistic scenarios, maybe of more difficult camera angles and things?
No, not exactly, because in the video you have seen like the background, there are too many, it's not clear, it's cluttered. Yeah. So I purposefully place myself on that background to show you that even the clutters doesn't impact with the normal webcam.
Any more questions, guys? One more or two? Yeah, Adrian?
Yeah. Yeah, good question. So as I mentioned, there are 200 plus sign languages. And let me tell you about American Sign Language. It used finger felling for just one hand. You just need one hand. So that's why it took British Sign Language, because both the hands are coming in, except for the alphabet C, which uses single hand.
Any more questions? I think there's too much of applause here, so I'm just going to let you go. You can take it off. So the next presentation, guys, is
Can you just plug that to your stuff?
Okay.
I'm just gonna. I'm just gonna have a quick look at audio for the next one. If that's all right.
Next, yeah. So
Yeah, that's okay.
Is there anything that can be done about the quality? Because it looks really.
Sorry?
Is there anything that can be done about the quality? Because yeah, on the screen it looks, I don't know, different than on the screen here.
We'll just leave that. So I think that's. No, not really. Sure,
Okay.
Sure about that. Sorry. Do you need the voice for the presentation?
No, not me. I think Helen needs.
Is that yours? Yeah?
Yes, that's mine.
Great, okay. I'm just going to go to that.
Okay, so guys, we have got the next presentation, which is Denise Tineji, and she is looking into using computer vision and predictive analysis for council pay and display parking. Maybe some of you that decide not to pay for parking. Someone's got something for you. Denise.
Thank you, Femi. So, as Femi introduced me, this is my project, this is what I've been working on, and I will be giving you an introduction and some background. In UK in 2020, there were about 33 million cars in operation. Therefore, finding parking has become one of the most repetitive urban problems. And on top of this, UK is on track to become net zero by 2030, resulting in an increase of electric vehicles charging stations that will have to be placed strategically across the city. Therefore, understanding the behaviors and patterns of parking will be crucial, for the councils. The research question was, how could the council better optimize or improve their pay and display parking with the use of computer vision and predictive analysis, resulting in the aims of creating an artifact and making further suggestions, as well as enhancing other types of parking, the electric vehicles, and the disabled bay spaces. Methodology and methods. So I've downloaded the video footage of a car park. I have 3 categories of data sets. They include the pay and display ticket machine logs, the EV charging transactions, weather reports, and holidays data, just to name a few. The artifact has been subject to usability testing and user experience questionnaire. I followed the literature review methodology. I've got ethical clearance. I have used DSDM as a project management approach. And I have used computer vision, more specifically image processing with predictive analysis and data analysis. The results show that the weather and time and day influence the parking, but no significant correlation was found for the school holidays. Comparing multiple parking locations could lead to further implementations that could be applied by the council. Also, discrepancies between the valid ticket counts from the pay machine ticket log. Also, against the video have been seen, but this has caveats around it. And also with the disabled base spaces, you can see when they are utilized and for how long, or has caveats around it as well. In terms of the EV, the plug-in time has been higher than the charging time. Also, there were preferred charging points, and also patterns for popularity and non-popularity days and times were seen. For the usability testing and questionnaire, all tasks have been completed, and they give a good average per scale. As you can see in the figure, the artifact scored above average to excellent compared to benchmark. Moving on, the artifact strengths were the life count, the vacancy predictions, the map view, and the individual location page. I've used LSTM and multiple vacancy for predicting multiple vacancy prediction intervals, and give an overall good evaluation. In terms of the image processing testing, I have obtained 86 to 100% accuracy, but this depends on the location used and the parking type used. So in conclusion, this tool will serve the local authorities, and it could be used for further implementations, such as revenue improvements, policies, funding, reducing the CO2 emissions, helping with the parking search issue, and even security. The citizens' view on the artifact has been positive from the usability testing, and the results support existing research and could also help existing research and possibly challenge existing research, but this has some caveats around it. As any other project, it has limitations. The acceptance of the system could not be tested by the consuls, as I haven't heard back from them. The generalizability of the results due to the data sets used, and the camera position, which needs to be a top-down view. So before I show you the artifact demo, I just want to present to you that the artifact is for two user types, the consul staff and the citizens. So the citizen will be a possible improvement, and the consul staff will split into general and system expert. So I'll be presenting you the general consul staff. Just one moment, please. Thank you. Okay, so this will be the page they land on, and they will have the user types. They will see where the instructions are and the dataset sources. They will select the consul staff. Then, for example, location RR with 24 hours quick summary. So in here, they can see the date range, they can see the weather details, they can see the life count from the video, and they can also see how the life count from the video compares with the valid ticket machine log. So you can see the discrepancies. You can also see the disabled-based spaces. You can see the count, as well as the tickets sold for each tariff time bracket and the amount collected. You can go to the menu and change the date for a different date, and the data will represent that date. Moving on, you can see an in-depth analysis for location RR. So in here, I'm looking at the whole data set, and I can see the total counts per tariff time bracket, which machine has been used for what type of ticket that has been sold through it. And I can also see the discrepancies between the video count and the valid tickets count. This will be the disabled-based spaces video count. I'm comparing it with the weather data. So, for example, the mean temperature, the wind average, the rain, and I can also see the rainfall classification, and I can see the daily average for that type. Same with the wind. I have a heat map for the weather, and the user can change the date so they can have a more in-depth view. And in here, I'm comparing my pay and display ticket machine logs with the holidays data from different perspectives. Thank you. The user can select a different location, for example, location A, and they will see the quick summary for location A, or they can look at all location for pay and display. So they will. And in this page, I'm comparing the location RR with location A from different perspectives, as you can see through the graphs. Now they can look at all locations for electric vehicles, so I can see which charging points have been more used than others. I can see the difference between the total time, total count per hour for the EVs, and also the total count per day for the EVs. And I can extract patterns of popularity and non-popularity. Okay, so now I'll be presenting you what the system expert consul staff will see. So, why is it? Okay, so they will choose the system expert, and they can see the information architecture of the artifact. They could see the files and flows used, and then here I'm explaining what has been done, how are the files named, and what data cleansing, where is those files, and they can also see the LSTM models, for example, the results, what prediction has been resulted from that, how are the files names, and all of those details. Okay, moving on, I can see you now what the citizens will see, and this is what the citizens will have access to. So as a citizen, I can choose location RR. I can see the address. I can even get Google Maps directions to that address. I can see the live count, and I can see the vacancy predictions. And this will be for both regular and disabled-based spaces. And I'm also informed that this location does not have an electric vehicle charging station. I can see the tariffs and how much you have to pay, when the charge is applied, the capacity for this location, and the popular days based on the daily average occupancy percentage for both regular and disabled-based spaces. Now I can go, as a user, I can go to location A, and location A will also tell very small text that location RR has more available spaces, so it's close by, you could go there if you want to. And everything on the map, so all locations on the map is basically shows you the live count, the prediction count, and the fact that does it have a electric vehicles charging station or not. And this is everything on the map. So just lastly, as any other artifact, I have artifact instructions. So in here, I'm explaining the user types. I'm explaining what can be accessed under each user type. And I'm also explaining that the graphs, most of the graphs are interactive, and I'm explaining how you can use this interactiveness. And that is it. Thank you very much.
You guys cannot be proud of yourself more than anything. So, questions for Denise?
Yeah. In one of the previous slides, you mentioned that the model accuracy was between 8-something and 100.
Yeah.
Could you comment about the 100% accuracy?
So, yes. It depends on what space type has been used. So for 100%, it was a disabled base space, and it was very little movement. So that's why it resulted in a high accuracy, because there was almost no movement, and all the movement that happened was very, it picked up as a correct accuracy.
As a follow-up to that, essentially you're describing that there was very little data that was changing. So would that mean that that was essentially overfitted?
For the image processing, yeah, there wasn't. So I'm using image processing. I have took the video, I took the frames, I have converted them in gray scale. I have applied binary image, and I counted the non-zero pixels, and I determined how many non-zero pixels do they have to be in order to decide that that parking space is occupied or unoccupied. So I do have caveats around it, because on some of the cases you could see people crossing, and that will be picked up as, yeah, it's occupied, but they are just the people crossing. Or there is another scenario where somebody left a trolley inside the parking space, so that is picked up as it's occupied. So that resulted in 86%.
So one more question following up with that. What he wanted to know is, because there are limited data, particularly for the disabled, was there an opportunity to have done maybe an overfit check? So things like cross-validation or something like that, to be sure that there isn't overfit, because there's limited data, and that might result in that 100% that you might have gotten that.
Yeah, that will be part of the further work. This is just V1, and there's a proof of concept of what it can be done.
One more question? Yeah? Yeah.
So I like the presentation. Just want to understand about the sort of customer or citizen side of the group. From my understanding, it's basically, so the person wants to know, I presume, how many spaces are in
So
like the interchangeable of spaces being available or not?
that's why I have the life count, which is right now, and then I have the predictions. So I have multiple predictions intervals, and they can, let me just stop it. As you can see in 10 minutes, this is how much is predicted. In 30 minutes, this is how much is predicted. These predictions are based on the ticket machine logs details. So it's a high difference because the video is a video, and it says there are only 55, but the actual machine logs say something else, which is the true data set.
Say that, for example, like a Saturday in town is very busy, so from data that I'll predict that certain times will be busier from that moment going forward.
So, yeah, on Saturdays, yes. You could use this, or you could, if today is Monday and you want to know how it's going to be on Saturday, you could say like a percentage of how occupied it is.
Okay, yeah, let's give it to the next So the final from the selected best project is going to be Ellen. And then Ellen is here to present to us on vendor malware in solid-state storage device available through e-commerce. So we all have got USB stick one way or the other. I think there's something you need to know about that, which Ellen might be able to tell you. Just plug that.
Let's start. Hold on to it. Yeah. Hello. Hi. So who uses USB devices that they've purchased from eBay and Amazon? Can I just see a show of hands from anyone who's bought one before? That's about right, yeah. I'm about to teach you in the next 10 minutes why you should never, ever do that ever again. So I'm going to begin my presentation with the rather wonderful Network Chuck, who's going to demonstrate just what a bad USB can do for you. No, okay, we lost audio. So he's very excitable, and you can see here he's got his USB stick, and he's going to explain to you it's one of the most dangerous tools that you can use in hacking. That he's going to show you in a moment his laptop, and he's going to very, very quickly, using a script, deactivate Windows antivirus for you. So obviously an adversarial hacker could do absolutely anything they wanted to at that time. Obviously he's very shouty. Here's his crap top, that he likes to call it, and he's going to show you here. So he's not touching anything. They'll plug your USB stick in from Amazon, and there you go. It has now deactivated Windows Media Player antivirus. So there are two famous USB malware that you've probably heard of. The first one, not this one, is called a rubber ducky. If you've ever seen the Mr. Robot series, it was actually the tool that was used in that. And the second one is the bad USB that Network Chuck is showing you here, which contains firmware malware. And it was actually that type of USB that was used in the famous Stuxnet attack in the Iranian nuclear facility in 2010. Also, it was found by Kaspersky in 2020 that the type of firmware called USB culprit can actually jump air gaps into secure systems. And overall, there are 29 different types of USB malware infections. However, none of those to date have been found in e-products, e-commerce products yet. So in order to test to see if there were viruses present in the devices, there were two methods. Those are the digital forensic testing and dynamic malware analysis. And in order to do that without any contamination between those viruses and the host system, a WeBTecker write blocker was used, and that prevents the host system and the USB from talking to one another so that it can't copy any viruses across. And the second testing was to test that USB in a live laptop. And in order to protect the BIOS, so that to prevent permanent infection that again may screw up those results, sorry, the bypassed operating system was necessary. And you can see that the Windows To Go installation was installed there on an external SSD, and the USB device was plugged into the laptop, but it is completely bypassed. It's running completely off the SSD. So I'm going to take you now to my website. There There we go. Woohoo. And we can see here there's a home page here and it explains the project, but it's also got instructions so that you can start looking into that yourselves. And the link is here for autopsy and it is free, so you can start doing that yourself. And we've also got the research here so that you can have a look at all the devices and where they come from and what was found. And you can see here that there's a range of devices from both eBay and Amazon. And you can see the ones on the red border were actually found to contain malware. And surprisingly, all of the red borders have the same type of malware infection and method, which we will look at now. Here. So 63% contained data in the binary of the unallocated storage spaces. So those are the spaces that you save your data into. And you can see that in that first image. That should be from the manufacturing floor, all zeros and all Fs in hexadecimal, and you can clearly see that it is not. So immediately that was a sign that there's something else going on. So the next step is to look at the binary itself to see if we can look at any of the signatures in that and extract out any files, which was done. I did manage to find a large number, around 3,000 Intel 86 and Time64 microcode, which has never really been seen outside in the wild before, but it is something that can be used with malware. There was a wonderful university group in Rare University who managed to prove 5 years ago that it can infect a computer very easily. The extracted files that came out were all the same file. They had the same file name. They were across multiple devices. Some were different, but there were at least 2 files found on all of those devices. Oh, sorry. And you can see here that when the live lab test with USB was popped in, we've got a number of events that showed up. And what you're seeing in that second image there is an example of an encoding error. So that's where there's been a problematic signature on the Telnet 3 client. And that means that the Telnet 3 client has been modified at some point. And you can't see that at any point on the usual Windows processes. You really have to get sort of deep into the way that you look at things, the dynamic malware there. And the events corresponded to some digitally signed processes that were also taking place. So I'm going to show you now. So this is the false positive results. So they do come up when you look at signature, and that's just so that we can see the difference between the two. So you've got here me typing in the binmort code, and you'll see lots of false positives. So it's looking at the header, and it will do a comparison to its library. I think we're going to get some up in a second. There we go. So those would not be counted. It's something that came up on random testing, and they were ignored. But I'm going to move on now to show you what it looks like when we have a positive result. And you can see here thousands and thousands of signatures of Intel 90 code flying through from one block of binary to the next. And that continues for quite some time. And there were 3,000 of those. So I'll just skip that. Ooh. Next is the XSTXR. So I'm just going to pause that if I can. No. So I then moved on to process monitor, which is what you can see here. And you can see here that there are lots of normal processes, but the HXTSR.exe, which is in the paper, you can have a look at it, is actually seen here very briefly, creating a very large number of files. And you can see that it says that it's popped the file into the Microsoft Communications app. And if I go to the next slide, I've now spent the last 2 weeks chasing a virus that's sort of wild on my network that's completely related to it. And we can see that Bitdefender has actually picked that virus up and given it a name. And we can see that there. That was found on 2 devices, and it is the exact same file that you saw modified after the insertion of a USB stick there. So this Trojan will arrive on the system, and it's a file dropped by other malware, which was what I envisaged was happening. And you can see that it does have the ability to send data to a remote control and command server, which is incredibly dangerous. So risk and mitigation. So I actually chased the manufacturers myself. I spoke to them. I went and sort of did a little bit of spycraft. And you can see here the manufacturers were all, and a lot of the retailers actually were all from China. And that includes all of the employees and across the registered businesses in the UK and the EU as well. And the companies have very unusual businesses. These 2 properties that you can see on the bottom here are registered businesses for those companies. They have 8 employees. I know this one here, this little flat here, very, very well. It's in my city. This is a very, very small 1-bedroom flat, and it would be very impractical to have 8 people working there doing USB distribution. And we've also looked at the mitigation. I've looked at mitigation here. So the middle picture is a vacuum packed device, and it's in coloured rice. So you will have that vacuum packed at the manufacturer's end, and it will arrive to you with a photo so that you can compare to make sure it hasn't been interfered with. We also really need to educate the public. So when I first asked you when you came in, have you bought one of these devices? A lot of you have. So I'm here today to say, stop doing that. Go to your local shop, buy the devices from there, even if it's at extra cost, because you are paying for that added security. And we also need to make sure that companies who are selling those are using that tamper-proof packaging. And we also, most importantly, need to collect more data, because this is just one of the many products that are out there, that are in e-commerce, that are in our homes, that have the potential to cause a major infection and to risk your data and your bank details and your health details. So we really, really need to start looking at more of those devices in the future. So in conclusion, there was advanced firmware malware identified by digital forensics tools, and that was identified as Intel 86 microcode. The devices contained identical files connecting them to the same adversary. The malware used digitally assigned processes to install other malware, and current mitigators focus on future prevention of cyber attacks on the public of the same kind. And that's it. And I'd like to thank Dr. Andy Farnell for his help as well. Thank you.
These are just fantastic projects, and we can, if we have to continue with projects which you all have done, I'm sure we would not leave here today. I'm sure some of you will be like, yeah, I need to show mine as well. There's just a limited amount, but you still have opportunity to show whatever project through your poster, and then people will come and ask you questions. That's a lot. Like I did say, it was a difficult session for us to kind of select the ones we just need to show you here. Any questions for Helen? Yeah.
When sort of purchasing sticks online, did you test it with like big brands and things like that?
Yes, I did, yeah. So if you actually go to the website, I can bring up the link again in a minute, you can see that those were the biggest brands. And actually, if you come to the desk in a moment, I spoke to two companies. I spoke to SanDisk and Kingston, who both said, absolutely, there should be no microcode, absolutely, of any description in a USB stick. That would be tantamount of a very dangerous sign of a possible infection, and that you should buy those from shops. You should go to places like Currys, PC World, you know, they're the same, but you can go there and buy them because they rely on their reputation, and without that reputation, they wouldn't be able to continue.
Just to be clear, no promotion?
No. Other shops, Tesco, everyone does them. Yeah.
Okay, any questions again? Yeah.
Can this artifact be deployed using an anti-directive environment?
The artifact is the website. So what I'm asking you to do is to go and look at a USB stick. Anyone from the tech community can buy one. You can use the instructions there, and then you can fill out the form, and it goes directly into the research box, and then we can start looking at those and then putting them on the website. And I'm really hoping that after all, this will be open data. So if other research is done in the future and they would like to have that data, it's all being popped into a SQL data set, and that can be given to people. And you can contribute with that.
My question is this, do you find out the pattern in which the malware using the antivirus, and what type of antivirus can it bypass, or is it all type of antivirus?
All types, yeah. This was only found after it affected all of the computer systems in my house.
So you mean that you pay thousands of dollars for antivirus for no nothing?
Because they found out a way around it, and that's why this firmware malware is so dangerous. It basically, especially if you use the Intel microcode, it's using a trusted platform model. So in order to decrease the complexity or the power from your CPU, it just goes straight through the back door. And 5 years ago, the encryption code for that Intel code was posted online. So it's given 5 years for someone to come up with a trigger to pop in there to put malware in that your IV is completely blind to, essentially. It goes through your CPU initially first, and then once it's on the CPU and it's installed thousands and thousands of files, you can then see a digitally signed process coming in and adding more and more and more to your system.
That's my question. How else does it install? How else does it install multiple DLL files without your permission? I mean, do you actually trace the pathway in which it executes commands?
So it's using, if you use an Intel 86 microcode, it's injecting that virus straight into your CPU. The computer is not aware of it. It's going straight in at the kernel level. It doesn't have to notify any other of the system, including the operating system, that it's there. It can just go straight in. It's one of the hardest types of malware to detect, and even these tools are very, very hard to detect it with.
All right.
Okay.
different if you actually do the work, isn't it? Yeah. You know everything. So it's fantastic.
Hi. I just wanted to know if your research was limited to just Windows or other operating systems.
So I used Windows operating system for this, as it's 90% of people use Windows machines, but I also implemented WSL, which is Windows sub Linux, to do it. So I used a dual operating system for the tests. Yeah.
Okay, so we're going to leave it at that. I'm just going to let you know that what is next is, so let's give it to Ellen, please.
Thank you.
Right, okay. We've been here since 9 o'clock, and I think 8:30, 8:45 for those that's come early. So I think we should try and get lunch. So the lunch is spilling into the presentation of poster, so you could stand by your poster or your stand, present. You guys should go and ask questions about projects. This is just few of these fantastic projects that we've got in this conference. So if you want to go and follow the conference committee guys, they take you to where the lunch is up there on the atrium, and then we'll start to ask questions. There are going to be employers around that will want to speak to you as well, so feel free to approach them and then show your skills. So I'll see you back in the next hour.
Hello.
Hi.
Just to check.
Yeah.
Is this sort of hour break that we've got now? Is that when you want us to be streaming? Or is it this 1:30 to 2:30 that's up in the?
Both of
atrium?
them, but this is the most important. Both of them are in the atrium, so
Okay.
they've started like that. So it's spilled into
Okay.
one another. So lunch and networking,
Yes.
and then people start to get their great
Okay,
posters
so-
ready. So those two together is what
Okay.
we're doing.
Cool. So if we're sort of setting things up maybe for the next like
Yeah.
10 minutes just to make sure everything's together. In there.
Yeah, that's correct. Yes.
Is the mic on?
We're gonna need that.
So it's about the British Sign Language, which I'm using the machine learning and artificial intelligence to translate sign language to text and audio. That's it. So most of the machine learning process is applied here, like data collection to data pre-processing, cleaning, and then evaluation, critical evaluation, as well as applying the model to a Streamlit application. So it's an end-to-end project which was done to analyze from A to Z sign and few of the BSL words.
Yep, my name's Mikey, so my project's on reinforcement learning, which is a type of machine learning model for controlling traffic lights. So I just did a talk on this just now. But basically, the problem is that we've got traffic lights, and then you're stopped at traffic lights for longer than you needed actually to. So there's quite a lot of research out there at the moment that tackles this problem, but a lot of them assume that they know where all the vehicles are at all times, which is one of the problems. I'm tackling multiple problems in this research. And what I've done is, so these blue lines here, they're basically just indicating the view distance of the traffic cameras that I've implemented in the simulation. And then on top of that, managed to implement a AI solution to help control the traffic flow. And if I open up my laptop, I could get a running demo quickly. Oh, some emails, you don't want to see those. Yeah. And open that up. So if I press play, you can see, so yep. As you can see that the AI is basically controlling which lane gets allowed to flow and then which lane doesn't. And overall, it performs better than without no AI, but my hypothesis was that it wouldn't outperform what's out there currently because the others don't have as much constraints. I put more constraints and limitations on my models to make it more realistic, so it's more practical to implement in real life. So that's sort of like seeing into the future and actually trying to create something or simulate something that's more realistic. So that's the idea behind it.
Thank you.
Yeah, cheers.
Hi guys, so my project is essentially about using machine learning to automate the contract review process. And I'm going to break it down really quickly because I know law can be boring. So essentially reviewing contract is a very time consuming and repetitive task. But if you can use machine learning to just sort of automate that process, it could save the lawyer's time and also save the client's money. So what I did essentially was, if you look at my methodology, was to take actual contracts and manually annotate them. So we reviewed contracts and decided whether or not a particular sentence was a prohibition, meaning don't do something, or an obligation, which means you must do something. And then after manually annotating, I put together all the annotations to create the master data set. And then I used that data to train several machine learning models, including the CNN and the LSTM model. And then after training the model, the best result was the CNN, which is the convolutional neural network. And then I used that as the back end of an app, which takes any contract sentence and then tells you whether or not that sentence is a prohibition, a permission, or an obligation. In terms of using this app, it can be used by lawyers. You could build on it to identify conflicts in contracts. It could also be used by clients, clients who don't want to be spending money to go to lawyers. You probably could just use the app to determine what your legal risks are instead of spending money, essentially. So, yeah, that's the basic.
Thank you so much.
So I've developed an e-learning platform that's aimed at children with additional needs, so autism spectrum disorder, dyslexia, things like that. And the idea is essentially to make a platform that their parents can use to make courses for them and tailor content specifically to their needs. So there isn't really anything on the market right now that's aimed at that demographic. So there's things like Twinkle, which are aimed at any kind of people looking to find teaching resources, but there's nothing aimed at people in that specific demographic, and they kind of fall through the cracks. So they're not able to access mainstream education as well because they are not suited to children with ASD and cognitive impairments. But yeah, so the platform's kind of aimed at those guys. And then we've kind of made a theoretical framework, which is the results of the project, in order to inform the creation of future technology and developments in that area. So they've got different aspects of content, communication and collaboration, which are a result of the study as a whole.
has been outstanding projects. And one of the strategies that we've got here in the computer department is the work, we're not just going to leave it and let it go, no. So this is why it is a university. So we have to progress. Most of this work that you see are going to be published next time. So we are going to get them published in international journals. And that will mean that the work is not just been done here to leave it. It's of international standard. And it will continue. So we will keep developing on it until we make our environment, immediate environment, a better place. So we are trying to unravel the future with AI, and that's what SCATE is all about. A lot of feedback regarding the project that's been looked at out there, outstanding project. The feedback has been enormously positive. So congratulations to everyone. So for the second part of the whole thing, we still have a teaser session, which is to be delivered by one of us here, Dr. Andy Fana. So he will be talking about cybersecurity and AI, or like climate change. Climate change is very important, as you know. So we are here to listen to Dr. Andy Fana. Thank you.
Thank you, Femi. Okay, hi guys. Right. It's brilliant to be at basically what is a AI and party, really. I'm absolutely blown away with the quality of all the presentations and the work that you guys have done. Absolutely outstanding. So I kind of feel like that really wrong, bad uncle that's kind of like going to come along and embarrassingly like do a big dump in the punch bowl, metaphorically. That's kind of my job, as I see it, as a scientist. We talk a lot about adversarial systems. You've heard the word adversarial quite a lot. How old is that? Well, maybe like 2,600 years, 3,000 years. If you go back to Plato and Aristotle, what were those guys doing? Disputation, which is where somebody sets up a bunch of ideas and somebody else sort of knocks it down. And it's through that process, it's an evolutionary process, that we get stronger and stronger ideas. We home in on the truth that way. So in that spirit, I'm going to be offering a slightly different perspective today. Let's start off with a few questions. Has anybody here actually got any formal training in ethics or philosophy of science? Has anybody studied that and got into it? Just kind of wave your hands if you're into that, if you're interested. Yeah. A little bit, good, okay, a few people are into that. But I expect to see a lot more hands now. How many people, and this could be positive as well as negative thoughts and feelings, have struggled ethically or thought deeply ethically about the work that they've been doing related to AI and cybersecurity and so on? Lots more people, right, okay, so this is an emergent field in this area. For us to question, now the most important question is why? Why are we doing this? What for? Yeah. Finally, are there any climate skeptics here? Anyone work for ExxonMobil or anything like that? No, good. Because well, otherwise, the rest of this presentation will make no sense to you whatsoever, and you may as well hit an early bar, really. But I'll swerve the punch. Let's see. So why am I asking these questions? Well, as well as being a computer scientist, I'm also a writer, written a lot in signal processing, this systems theory, that kind of stuff. The current book is Ethics for Hackers, and hence this connection here to what we're doing today. Want to think about like the kind of harms and motives and where we're heading at. You know, this is not a new thing. Again, this is very old, tech critique. You have writers like Martin Heidegger, Jacques Ellul, Neil Postman, people like that who've questioned technology, questioned the purpose of technology and the trajectory that we're on, you know, kind of what we're doing it for and why we're going there. Right. So some names, some people. This guy is a grandfather of cybernetics. He's Norbert Wiener. I won't bother to read his quote verbatim, but you can see Norbert Wiener is an extremely intelligent guy, very, very rounded, really into sort of biology and evolutionary theory, the reproduction of systems, the same kind of questions that Quine and Turing were asking about whether systems can be sentient and whether systems can be directing and so on. But look at his values. You know, a deeply humanistic person who was extremely worried about the implications of the work that he was doing. He thought that actually that the trajectory of cybernetics tended towards fascism, necessarily. Let's have a look at another guy. Adam Smith, right? Founder of economics. But again, if you actually read Adam Smith, if you get deeply into Smith's work, what you find is this incredibly generous, magnanimous, humanistic figure, obviously influenced by Christian values, deeply skeptical about the future for what, and I think he would abhorred what we now call kind of neoliberal, libertarian kind of versions of capitalism, surveillance capitalism, and all that kind of thing. Absolutely detest it. Another guy, we all know this guy, right? The Fourth World War will be fought with sticks and stones. Yeah. There's Einstein the mathematician, and there's Einstein the person. And if you look at Einstein's work and read his writing, what do you find? You find somebody who's passionate about human creativity and deeply worried about our ability to steward the technology that we develop. Okay. You know, going back here for a moment, a lot of people would immediately think in terms of these harms that I'm going to start talking about things like defense and medicine in the context of ethics. And maybe no, you know, maybe that's getting it wrong. I mean, I'm no stranger to that. I work on defense projects, influence, intel, that kind of stuff. And, you know, you can see now, well, for our friends in Ukraine, that is a complex question, but it's not necessarily one where you would, I'm not a pacifist. Okay, I'm not coming at it from that angle. I'm coming at it from somewhere a little bit different. And I want to say that what we see here with these very smart people historically is that they've been the ones who questioned what they were doing their work for. Do you notice that? There's a pattern here. That the ones that stand out are the ones who are skeptical of what they're doing. Now, there's this gang here, Union of Concerned Scientists. Now, cyber and AI are identified as emergent existential threats, meaning that along with climate change, and here's the connection, we have the ability to wipe ourselves out with the things that we do. And this is the road to hell is paved with good intention scenario, is that most of what we're doing is, of course, the best of intents, right? What we can see with this is that there's not a great deal of room for these questions to be aired and raised. For example, Google, I don't know how many chief ethicists they've got through, but it seems to be an unsustainable post. So as soon as you start to talk about this, you get fired. So there's a sense in which not only is it not on the radar, but it's kind of pushed down somewhat. And what we really have is a kind of domination of the debate by a very small number of powerful interests, okay, what we'll call tech giants for the purposes of this talk for now. Okay. So, you know, experts have a hard time recently. Well, we should listen to them. Here's a few of them speaking. Sir Tim Berners-Lee, creator of the World Wide Web, you know, expressed his disappointment and, what was it, regret. I mean, that's so sad. That Sir Tim is expressing regret about the trajectory of the web and where we've ended up. Ian Somerville, author of 9 editions of software engineering, they literally wrote the book on software engineering. It was my text in the 80s when I was at UCL. Along with kind of Fred Brooks and Margaret Hamilton, he defines most of these. Software engineering is for the big institutions now, and he says he wasted his life. He looks at modern software. And he wrote a post recently that just literally made me cry. He said, I feel like I've wasted my time. So what should we do? We should listen to these people. Here's Dana Meadows, limits to growth. There are limits to growth. Liz Truss, listen. Well, limits to growth, okay. She went up against a lot of opposition. You know, climate change is like 60 years old. We knew lots of the stuff about climate change 50 years ago at least. And it's been a struggle for us to come to terms with that against the suppression of that knowledge by the companies whose own scientists, like in Exxon and stuff, researched all of this stuff and knew about it, and then managed to keep a lid on it. And Dana Meadows, her work again came up against what we see this a small group of interest, small group of powerful interests who are able to set the agenda. This is nothing new. In this East India Tea Company, United Fruits organised coups in South America to keep the bananas going. And so, why should we expect anything different from big tech? They give us free emails, so they seem like nice guys, right? But the cake is a lie. Okay. A graph. We've got to have a graph. So here's one. It is symbolic. Don't read too much into it. This is stuff going up. What's going up? Lines of code are going up. Exploits per line of code are going up. Code is getting less secure. A total number of exploits is going up. So we're building complexity, and as complexity increases, we need more powerful hardware to run that stuff, which opens up more opportunities for us to run more code. There's some good things to that, but there's also some bad things to that, because what's happening is we're building non-resilience, irresilience into our systems. And what we're getting is very much like climate change, is an accumulating debt. You've heard the term technical debt. Well, think of technical debt on a global scale, in which the massive interconnected systems we've got, and this is basic software engineering, your module coupling and cohesion gets out of sync. And you've got systems that are very non-resilient. So resilience engineering is now becoming a thing. It's like, what happens, like literally if the internet went off tomorrow and stayed off for 2 months, what would happen? Would we have food riots in the streets? What would happen to our supply chains, and so on? Okay. So building too much dependency into these systems is a bad thing. I'll kind of skip those. It's a more real-world example. I teach this course called Digital Self-Defense, and people say, hey, I would love to come to that. Love to learn how to secure my phone and not get tracked and maintain my privacy. Sign me up. And then they don't come. Even when they paid, they don't turn up to the lesson. This is strange, what's going on? It's a mystery phenomenon. And it took a doctor friend of mine to explain. She said, we do the same thing. Like we run these seminars on obesity and diet and blood pressure and heart disease and cancer. And they're delivered by experts who are, whose time is incredibly precious. And then people don't come. And if they just came to these sessions, we'd have an amazing preventative medicine, we'd save lots of lives. Why don't people come? Well, it's because like, ew, who wants to know about that? Right? It's a key kind of difficult thing, right? Literally, people don't come because you're thinking about the bad things now when we could do something about it is always much more painful than dealing with the consequences at some deferred point. Now there's solid theories about this in game theory and economics and stuff. It's a deferred bias and things like that. But it's a kind of fundamental flaw of our species is that we're able to do this. Reluctance is also, like, think of it from a physical point of view. Something that has a mass and is acted on by a number of vectors of forces will only move when acted upon. And progress is a vector, right? We talked a lot about vectors in AI today. Progress, there's no abstract noun of progress. You can't just say, well, that's progress. Well, progress towards what? In what direction? And when you look at intersecting spheres of interest, one person's progress is another person's dystopia or regression. And people change their ideas very, very slowly. Large groups of people change slowly because they have this reluctance, this inertia to them. All of us have this small few ideas that we don't want to let go of. We're reluctant to drop them, and the saying goes, well, it's hard to convince a man of the truth when his salary depends on believing otherwise, right? That's so true. And so take two-factor authentication, that's an example. If you haven't got the memo, that's not a thing now, right? Because if you knew about the weaknesses in SS7 and GSM and stuff, you never would have dreamed such a crazy idea in the first place. But the point is it took so long for that information to get through and for the models to be analysed and for people to go, oh, hold on, that is a dumb idea, isn't it? Well, maybe we shouldn't do that. Right, so what I mean by distortion is like the distortion of a lens. Technology is not just a thing, it's a lens through which we see other things. So if you run the biggest search engine on the planet that everybody gets their results through, and you get to select those results. You get to change the way that people see the world. Okay. What we therefore get is that a lot of, the popular literature on trajectories in AI and cybersecurity is written by the very companies that we want protection from. We want protection from them because they are very, very big and very, very powerful. Okay? So how can we deal with this distortion? Here's a nice example, as the comedian Stuart Lee said of Vodafone's Guide to Online Safety for Children. It was Mr. Fox's Guide to Henhouse Security. And it's like, well, yeah, all right, because, like, you know, they want the kids using them stuff all the time and giving their personal data and so on. Like so. And the danger that we have in education, by being entrenched within this distorted view, is that the only people that we're making is more guards for the castle. We're not going to turn out graduates and research which is provocative, which is critical, which is innovative, which is anticipatory and sees new things coming, because we are kind of have this kind of blinkered view. Okay. Markets don't work very well to solve this. As you can see, the incentives aren't great. We haven't talked too much about business and how to monetize things, but many of them end up being conflicting with the value systems that we've got. What we also get is the problem that markets lead to marketing. And marketing is a form of distortion. Think of these terms: AI, smart, ethical hacking. That's my personal bugbear. You know, we don't do any ethics in ethical hacking. You may have noticed that Immanuel Kant and utilitarianism and Jeremy Bentham are not on the syllabus when we sit down to hack things. And the danger here is that we're just generating we're making the next generation of cyber criminals, because students will leave and they don't have any guidance. And then they will realise that their skills are very, very valuable, but maybe going to work not for the people that we thought they were going to go and work for. Right? And as academics, we should and do know better. But of course, you know, we all chase that buck. And where is that buck? Well, it's choosing those right impact terms and so on. Okie dokie. Yeah. Who's seen Killed by Google? You know, the Google graveyard. Yeah, okay, right. So there's a litany of murdered sites. What's going on here is that we believe that we're engaging in a market economy in which we have a supply-demand thing. So people would want something and they'd ask us, hey, can you make this thing, techie? And we go away and we work really hard and we make it and we give it back. So here's this thing, the solution to this problem that you had. It doesn't work like that. It's completely the opposite. It's a possibility-driven culture in which we have solutions looking for problems. We discover something and then we think, well, how can we sell that? And then we go out and find a way to create a demand for it. And so what we get is this inexorable churn, this instability. If you've seen kind of Schelling's models that will never settle on a state, this is kind of what's happening with Google, are brilliant at generating new ideas and products and putting them out there, leaving them up for a couple of years until lots of people are very dependent on them and then axing them and just leaving people hanging. So what we're effectively doing in tech a lot of the time is we're doing R&D in which we're using the entire planet and culture as our personal playground. And that has ethical implications. Let's run through a few of these quick. This is how we respond to this kind of chaotic situation. Our world seems illegible, it seems unpredictable technologically, so we engage in denial, avoidance. I've mentioned these, compartmentalizing, we put things into boxes. We just throw up our hands in the face of complexity and say, you know what, this is all too much for me. And so we end up engaging in what sort of superstitious behaviors and quite irrational. And there's a paradox in technology that the rational leads to an irrational response. Yeah? Learned helplessness, comforting stories, and appeals to authority, especially the empty assurances of unreliable authority figures. Yeah, that's a real danger. Okay, we will say these things. Oh, hey, it's just a glitch. Oh, these are unprecedented times. Yeah, unprecedented times. Well, every time is unprecedented. This never happened before. And judging by the look on Femi's face, it will never happen again. But you know, these are little things that we deliver, right? We say, you've got to break some eggs to make an omelette, right? Move fast and break things. Broken is the new normal. Creepy is the new cool. Everyone's doing it. The idea of technological determinism and so on. None of these, absolutely none of these, are sound ethical stances to the problem that we're talking about. Neither is this phenomenon of productization, in which we turn solutions into symbols of those solutions. What I mean by that is that we have products instead of principles, which is a very brittle kind of education and research, because once you go out and the world changes, which it does very, very quickly, those things kind of cease to work, whereas principles are enduring. This can lead to like kind of cargo cultism and as I said, sort of wishful thinking and almost quasi-religious behavior around technology. Technology is becoming almost a religious thing, right? The end product, the end result of this, I think many people recognize as domestication. An incredible lack of respect for the so-called user. What's the film? It's the Social Network, Social Dilemma, in which he says the drugs industry is the only other industry apart from tech which has users, right? So what does that say about us as users? Okay, that we are dependent, that we're effectively quite helpless. We have these computers which have become appliances, and we've moved away from the digital literacy of the 1980s and so on, which sought to educate all of us as make us very literate in computing, and regressed back from that towards kind of users of appliances in which there's a war on general purpose computing. We live in walled gardens and so on. So let's talk about some responses to this and kind of where I'm coming at in terms of policy and how do we manage and direct studies and research in universities so that we end up aiming towards a genuinely greater good, that we don't find out that there are things hidden away within the projects that we've got, which ultimately are facilitating dystopian futures, fascism, mass surveillance, bad things. Okay. Well, there's this notion of digital self-defense that I've mentioned. Several of the students have been working on this. This is bringing cybersecurity back to the individual so that it's something that's mindful and you're thoughtful about in your day-to-day activities of like shopping and what the kids are using computers at school for, that kind of thing, right? One of us in Ed very awesomely managed to... Who was the minister, Ed? Who was the minister who replied to the civic cybersecurity and self-defense? Do you remember? Amazing. Well, there's a smart person, right? We've managed to get one of our members of parliament to recognise and use the terms which we've been cultivating here. Civic cybersecurity and digital self-defense. Civic cybersecurity is cybersecurity and awareness of things, algorithmic choices, and how big tech is working in your daily lives. Awareness of that and an understanding to take a defensive posture for your human rights, for your privacy, for your self-determination, for your technical mobility, stop you being stuck in walled gardens, that kind of thing, right? There's been actually a lot of really good movement lately, politically. So just off the top of my head, there's the new online safety bill, which is ostensibly good. I mean, some of the implementation is going to be a shit show. It's going to impinge on speech and do bad things. But overall, it's a good instrument, and it's a positive direction. The EU interoperability framework is magnificent. I think what Europe are doing is great. We're moving towards forcing interoperability. There is no reason why you should not be able to use Teams with Zoom, and anybody like my Jitsi client or whatever should be able to interconnect with that. That we shouldn't have standards like how we did in the 1980s for email and communication systems. They should be interoperable. And so there's a strong force here building to make sure that this kind of stuff happens, so that we can have choice, make informed decisions and so on. Right, last slide. How do we address the bad effects of technology on human and cultural environment? What I'm thinking of is that as climate change is a threat to our real environment, there are threats to our cultural environment in our digital lives. And there are also tipping points beyond which we're going to find it very, very hard to recover. Dependency is one. As we have in climate, we have dependency on fossil fuels. But pollution. Now, Bruce Schnaub, the security researcher, was one of the first to identify data as a form of pollution. Data can be a liability as well as an asset, right? And it can be a pollution. So are we able to change our viewpoint to be able to see big tech, AI and surveillance, not ambivalently and objectively, not just as good things and panaceas, but also as potentially first-class threats? Can we reform digital literacy? Can we reintroduce a new digital literacy, if you like, an everyman's cultural view of it? And to that extent, I believe very strongly that this is a national security issue. National security, if nothing else, is nothing but the sum total of every individual's earned security. Right? What is the point of having a load of dishes at Cheltenham looking at satellites if your granny can't shop safely online and your children at school are being spied on? This is corroding the fabric of society at a much lower level underneath the radar. So I think it's a real national security issue. And, oh good, we'll have some questions, that's great, yeah. Is that 5 minutes to just shut up for me and then we'll have questions? Yeah, okay, cool. Okay. So can we move security away from being an abstract noun? Security for who, security from who or what, and security to what end? Those are very, very important questions. The same thing should be applied to algorithms and AI. We need to question whose interests they serve and philosophically what their telos is. What is the end of them? We don't know the kind of technological society we want. We can't make those choices, right? A smart city can't just be smart. I mean, smart about what? And why is it smart, right? What are we trying to do? Let me give you an example. I don't mean to disparage anyone's work that they presented today, but we've seen 2 examples where we wanted to basically facilitate potentially more traffic. Yeah, we could increase the throughput on the roads and increase parking. But then we're increasing the number of cars on the road, right? Because the use will always expand to fit the capacity available. We know that from all sides of systems theory. So I'm just kind of putting that out there as the kind of questions that we would need to ask right at the very beginning. Okay. Okay. So to that end, I have designed a new course. It may be something that's delivered here at Solent. I don't know. It is computer security, cryptography, and counter surveillance. It's a very mature, joined up version of cybersecurity that takes these kinds of viewpoints, incorporates civic cybersecurity, personal digital self-defense, and is for kind of people like journalists, police doing investigations, people in service, health professionals, anybody who has to handle data and deal with it, to think in a very much more mature way about how they use technology and how they protect data. Okay, that's it from me. Thank you. I'll take some questions.
Thank you very much, Andy. So we've been here since morning, 9 o'clock or 9:30, and we have had a good and fantastic lectures from different speakers, ranging from the keynote speakers to the student presenter, fantastic work so far, and then this is from Andy, which is one of us here. I want to ask, has anyone got questions for Andy so we can carry on? Yeah.
First of all, thank you for great presentations. question would be, do you think that's actually achievable? Because humans tend to choose convenience over understanding when they can.
They do value that. They do value convenience over understanding. That's a failure of culture, not necessarily education, because we have great education, as you know here. Is it achievable? Yes, it's achievable because it has been achieved, and just axiomatically, anything that has been achieved can be achieved. So we've had digital literacy in the 80s. What happened in the 80s, I think, was that it spawned a generation of people like myself who grew up and they formed new industries like the games industry and web and things like that. And it was so disruptive, I think the incumbents were caught with their pants down. They said, we're never going to let that happen again. It kind of happened in the 90s with the web, which led to the Arab Spring. And so I don't think anyone anticipated how disruptive digital literacy would be. So I think there is a kind of a force against it because of that, but I certainly think it's possible. And I'm very optimistic, and I hold people's ability to understand things in very high regard. I have to be. I'm a teacher. Right?
In the same thing, like there are things that didn't go that way. So, for example, say like cars, like ABS systems, like a braking system, used to be not a thing, and everybody drove just fine. Now it's in every single car, and nobody cares how it works or why it works or what it even does. They just know that they press the brake and it works better than it used to. So it's a similar way, AI and all that.
So long as that advance has no negative effects, then that doesn't matter. That is progress. Why would you kind of go and use a shovel when you've got a JCB? But if it does lead to problems, then we need to question it, we need to unpack it, and we need to understand it, because ignorance will not help.
Thank you.
Yeah.
Any other questions?
Yes.
Yep.
Yeah. Talking about the area where you talk about creating the problem and also creating the need to solve the problem.
Yeah.
Could you throw more light on that?
Yes, this is a really interesting thing, Francis. It's like, are we a solution-based society in which this is the classic way of looking at things. It's the dialectic, is that we have a problem, we research the problem, we come up with a solution, and then we deploy that solution. And ideally, the problem would go away, and that would be the end of it. There's two things that can go wrong here. One is that the solution itself leads to more problems. As I was kind of explaining earlier, at least adds more complexity. And so we can sometimes call that solutionism, in which we end up actually bifurcating into more and more problems created by the solutions. The great one of that is in The Simpsons, isn't it? Which is kind of, what is it? They keep introducing these predator species in Springfield, and at the end of the day, so well, that's the beauty. When the winter comes along, the gorillas just die of cold. It's just so inhumane in this application of gratuitous application of solutions. That's one danger. The other is that we are not problem-driven at all. We start with ideas which can be marketed, which we can make money from, and then we create problems to serve that. And there's lots of that around. I can give you lots and lots of examples. The Japanese have a word for chindogu, which means useless tool. It means kind of a piece of technology that you make kind of because it's immediately desirable and you think you want one, and then you think, oh my goodness, that's actually completely useless. And it's really regressive, and it's just another piece of landfill fodder to kind of become e-waste, right? So.
One final one, and then we'll let Andy go. Yeah, go for it.
Yeah, so it's a bit of a multifaceted one, but in terms of like machine learning, like you mentioned, we'd have the problem, and then we'd have the model, train the model, test the model, save the model.
Yeah.
How do you apply that to ethics? And in the sense that you might have something which is feasible now in terms of ethics, but how do you protract that for 10 years' time, 20 years' time, and who is the one that should be responsible for saying this is ethically good or bad, etc.?
Okay, so I'll start right at the end with a sort of appeal to authority. There is no such authority. Necessarily, that authority has to be yourself. And the ways in which you can exercise that authority is in choices around technology. You can choose to use something or choose not to. So, for example, think of like the cashless society. what is the consequences when you have no actual physical cash? You have, you can't pay waiters, can't tip waiters, you can't give money to homeless people, you can't donate to charity, you know, an event you can't teach your children about money because they can't account anymore, you know, and there's no, you know, so you follow this through, you know. Again, think about, say, facial recognition. What's the consequences when everybody has the facial recognition? This will happen, hear me now. Will have this on their phone, and you'll just be able to point it at any random person in the street and know who they are. Now you're back to basically living in a village. This is how we lived sort of 300 years ago. That wasn't so bad when you know literally who everybody is, but you need to think, well, what would the consequences of that be in developing that technology? And with machine learning, what you're doing, you know, is any data set is necessarily finite. And so what you exclude from that data set, and we've seen this with the kind of the racist hand dryer, haven't we, and the racist facial recognition and so on. It's what you choose not to put in that data by your sampling has implicit ethics in it. It's immanent within your choices as a researcher. So you may not be aware of the things that you're doing which lead to ethical questions later on. But it maybe if we had this stuff on the syllabus right from the get-go and people thought about it more, then those things might not happen. No. I hope that kind of answers your multifaceted question. Thank you.
Okay. So yeah, we would want to put a stop to that now, and then if you go into the questions, obviously Andy is still around, and then we can always go. So, yeah.
Thanks, Connie. Got him?
Right, okay.
Don't worry, you get it later.
So, yeah, you've managed to listen to fantastic presentation from the selected outstanding projects. Like I've mentioned earlier, we have got several projects which are outstanding, and it was still difficult for us to kind of select the ones that are going to present to you today. And we managed to get us 5 out of this for this presentations for the presentation they've done today. Having said that, we want to appreciate the guys for taking extra time. So obviously, it means that these guys have presented their posters, as you all have done, the delegates. And obviously, they've done extra again by having to prepare a presentation and justify their work in your presence in the plenary session as we've got it. So now I will have to invite our Pro Vice Chancellor, student and teaching, who will be presenting prizes to these guys. So we have managed to come up with overall best project. Every project is good. But we managed to look at a couple of things to come up to this final best project. So we've looked at the presentation fluency. We've looked at the quality of research. We've looked at the impact of the project on the society, and obviously the audience engagement. So we would have certificate presented to these guys in the order of, in descending order, I'll say. So we'll have to give you the certificate to the guys that came 5th, 4th, 3rd, and obviously the first one. So before we start to call you guys for presentation, I would want Pro Vice Chancellor to at least say 1 or 2 words, if that's okay, and then we can present the...
Sure. Well, hello everybody. Nice to see you all. And wow, it's impressive you stayed the whole day. So just hats off to you, because it's when I've been past this room and this building, and you're still going in, and you're still. It's really impressive. I'm so proud that you got to study on this course here. I'm so proud that you get to be the future from Solent. I remember conceiving this course with some fantastic people a few years back, and you know, to see you guys, it's like turning theory into practice, which is what your studies are all about. And so I feel, although you don't know me, but I just feel like I've contributed, admittedly on the peripheral side, come in, swan in on the last day, but to say so glad to welcome you to Solent. albeit at the end. But so pleased to to be able to see so many faces. I've read through your work. I mean, fantastic. I'm so impressed. And I was talking to somebody the other day about the future and the role AI plays in creating some really smart answers and some very important and life-changing experiences for people, and hopefully contribute to health, the climate crisis, or as well as everyday life. So just a big hand. I'm just going to ask you to applaud yourself, okay? So, because that's amazing. I'm really honoured to be asked to give prizes out and to recognise your great work. And it's always, you know, I just want to say well done to everybody. And there are a few certificates to hand out. So I'm just going to hold them, and while somebody else calls out the name, I think. Or do I call out the name? Yeah. Okay, so the first prize goes to, it's not first prize. This is the what? Fifth prize. Working in order backwards, sorry. It goes to Denise Sinegi for the use of computer vision and predictive analysis for parking spaces. Well done, Denise. Thank you very much. You want to have a... Yeah. Fourth prize. Yeah. So the fourth prize goes to Helen Pluys, for in-vendor malware present in solid-state storage devices available through e-commerce. I mean, that is a long sentence. Well done. Thank you so much, Helen. Well done.
So that's the second runner-up, and then that comes with the gift as well.
Okay. All right, so the second runner-up is Michael Law. Reinforcement learning for multi-intersection traffic light controls with lane area detection range. And these titles impressive. Michael, you also get a gift as well.
That's great.
So thank you.
First runner-up goes.
Okay. And the first runner-up goes to Cherise Graham for natural language processing for legal development review, categorizing deonetic modalities in contracts. Well done. And there's a small gift for you as well. Congratulations.
Your best project first, Shani student, and then she has plan innovation.
Okay. Well done. I'm going to just read out your project. Hand chat, push your sign language. And you get quiet as well. And smile for the camera. Well done. That's amazing. Congratulations. So that's thank you from me. And again, a huge well done to everybody. So proud. Thank you.
Thank you very much.
Okay, guys. As you all know, it's been a busy day and it's been fantastic so far. Guys, please. It's been fantastic so far. Like I did say, what we are doing is we are obviously, guys, so we are obviously creating our own community and then not just creating that community that is going to have to impact or constitute better solution to societal challenges. So we are building on that. And you happen to be the pioneer of our SCADE conference, and this is going to be a continual thing. It is embedded in the course. And I'm sure you're all proud of yourself in terms of what you managed to present. So from Shani's project to Sherry's project to Michael to Helen, to Denise, is quite impressive. The feedback so far has been outstanding. And there's too much that you can still do. So what we're doing is to make AI and maybe computing to unravel the future with AI and computing. That's just what we're doing. And you have tried to make us proud. The work is not going to be ending here. As you know, we are setting up our AI lab, which is going to be helping to impact our community. So the work you've been doing is not going to go just like that. We are going to be pushing them out to try and help our community with it one way or the other. And for the first time, we are making it a standard that most of your projects are to be published in international journals. So we'll be working with you guys. And at least we've selected close to about 15 projects that are to be published already. So it shows the standard of project that you have produced. So I'm quite impressed with you guys. I cannot say more. The prize has been given. What we need, the next thing is going to be a feedback session. So I've asked you to share. So what I'll say is we've got the feedback for this conference. We will want you all to kind of feedback one way or the other. This will be sent to you, or you could always get to go on it now and then just do whatever you want to do, perhaps feedback on how best we could improve this whole thing. So one other thing which I would like to make clear to you guys is it's not ending here in terms of our community. The Skate Conference, you are going to have the next cohort join in. You're already there. And then the community continues to grow. We are not just letting you go. So once you go out there, you should perhaps come back to contribute to your university. So it is your university, Solent. And we would want us to kind of start building on whatever we've got to improve and make a good societal impact, like I mentioned earlier. A lot of you have kind of faced a serious challenge in trying to get this done. And I always tell you guys that what is worth doing at all is worth doing well, which is what you've all seen today. I am very sure you guys are so much proud of yourselves. If I'm correct, then you want to applaud yourselves. And fortunately, you've not only made us proud, you've not made yourself proud, you have made us proud as well. Because all the external companies, employers, or whoever that have come into Solent today to look at the project, they've all been coming back to me and saying, oh, this is outstanding, this is fantastic. Can you imagine student did this? And the good thing about it is these projects are not just projects. They are solving one problem or the other. So, and chats, some people are going to be integrated into the society. Lawyers, you're going to spend time having to kind of get your contract read, but you've got the device or a system that's going to help you to get all that sorted as quickly as possible. Traffic, more than 80% of you raise your hand that you do drive, and you do encounter the same problem, which is having to sit by the traffic light when there isn't any traffic. So we've got another one around paying the council, the citizen managing the car park and things like that. And then we've got about cybersecurity. You can see how interesting that is. A lot of you aren't aware of how much this USB stick that you purchase, how it actually impacts your system. Once you plug it into your system, you don't know how much it does affect your system negatively or your computers negatively. One of our students has been able to unravel that and let you know. So it is massive. And there's been a lot of other projects which actually ties into the university research strategy area. So we're looking into the human and function side of things, sustainable business and things like that. So there is a lot. And it's just going to get better, and we are going to be improving on what is actually here. So I'm just going to cut it short here before I get our dean to kind of give us some form of closing remark. But before that, in the feedback session, I just want to hear one or two things regarding perhaps the project that's been presented or any other thing that you guys might feel we should respond to. Just one or two feedback from you guys regarding the project, comments, questions that's been presented, or the entire conference as a whole. Comment or questions, anyone? Yeah? No comment, no feedback, no questions? Anyone got any questions that we could attend to? So as you know, one of the things we are promoting in computing department is more of the co-creation activity. And like I did mention, we don't just do things. So we are making sure you're involved in whatever, because we want to serve you, we want to help you. So if we are helping you, you should one way or the other participate in what we are trying to give to you or whatever we're using to help you. So this is really, really an impressive thing that you guys have done. We still have the closing session, but before I get to the closing session, I would want to say a big thank you to the conference committee, which is mostly students. More than about 16 of you are students. So just to make it clear, you've been telling me, yeah, this conference is great and all that. It's all been planned by students. I only managed to guide them. So it is co-creation. So let's give it to them, please. Unfortunately, I could not mention their names, so about 16 of them I've mentioned, but you know yourself, and their name is already on the conference proceedings, so you can always look at that. One other thing I want to mention before you go today, or before I call the dean, is, like I mentioned earlier, we are starting our AI lab. And that will mean the progress we make in the AI lab will lead to turning that AI lab to a proper research center. And you all will have to participate and contribute. So whether you're leaving or you're just coming in or you're just, you are the current student, you will be participating. Like I did say, the conference is planned by students. Our AI lab is going to be built by students as well. And this is what will continue by improving our research culture. And I would want to say a big thank you to you guys for having to do all those things that you've been doing so far and making us proud. Now, I'm going to need to invite the dean to give us some form of closing remark. And he's able to make a speech about the project that's been presented so far. So if you welcome our dean, Paul McFank, please.
I think when Tommy says the word speech, he's bigging it up a little bit too much, really, there. The actual item says closing remark, and it's singular, so you're only going to get one. Okay. Yeah. No, I mean, I said this morning when we opened today, you know, how proud I was about that. And that's not a word that you often hear people use in these contexts, but I really do mean it, because we've come from very small beginnings in this field just a couple of years ago with Shaquille and a few others, Nana actually, working on a bid to put an AI course on our portfolio, to in just a couple of years to be where we are today. And within those couple of years, we've had a global pandemic, we've had all sorts of pressures and constraints put upon us. So it's remarkable that we've come so far in such a short time. And I am genuinely proud, of my team who have put this on stage. I'm not going to say too much because I know Stuart's got a vote of thanks in a minute, but thanks, Femi, and thanks to the team. But also to you guys, your engagement has been truly impressive. And I'm not just saying this, today has been a really impressive day. I've sat here during the whole piece. Okay, I had to go away for about half an hour. But it has been truly inspiring. Some of the ideas coming up in those projects, I've been making copious notes. because they're just great. They're real solutions for real problems. And that is key to Solent. That's our USP. That's who we are. That's central to our belief. Obviously, students are the most important thing to us, but the application of knowledge and theory into praxis, real-world education, finding real-world solutions. It's really quite humbling to see some of those ideas. And when you think about the last couple of years and what we've been through, we're going to need people who can find solutions to new problems. And I think I'm speaking to most of them in the room today. So finally, I think we said thank you 25,000 times in the last 10 minutes, but thank you for coming today. Thank you for participation. You are the best ambassadors we've got for this university, okay? So go out there and tell everybody what great things we're doing here and what achievements we're encouraging you to do. So thank you very much.
That was a great speech from our Dean. It was meant to be a closing remark, singular, and then it actually turned to a speech as well. So that's great. So we are almost getting to the end of it, but we wouldn't close it up without calling onto our head of department, which is head of the programs that you all are doing. He has been massively supportive in making sure we get this to where we are at the moment. So you are testifying that we've managed to give you the best, and you've got the best from us, and you want to carry on getting the best or producing the best. But there has been underlying strategy underneath you getting all this you're getting today. So Stuart has played a massive role in having to achieve this. So I'll just call him to give the vote of thanks, and then we'll move to the next event after that. So I invite Stuart Ray, Head of Computing, to come and give the vote of thanks.
Thank you. Good afternoon, everybody. So what you've just heard is a load of people saying thank you, and Femi's just asked me to come and propose a vote of thanks. I'm always confused by the phrase, a vote of thanks. Do we have to, all those in favour of saying thank you? Only 3 of you. Okay, well, that's the end of my bit, I guess. No, I just want to echo what a few people have said already today. I've been in and out today, but I had a look around the projects earlier. Some stunning work, absolutely brilliant. And you are indeed sort of great representatives of the kind of work we do here at Solent. You should be very proud of yourselves. Femi has asked me to do a vote of thanks. There are a few people I should thank. And I don't want to turn this into an Oscar acceptance speech where after about 3 minutes you have to get the orchestra playing to get me to get off. But I do think there are some important people that should be thanked. First of all, Femi mentioned them, but the organising committee, their names are listed in your programme. I'm not going to embarrass myself or you or them by reading those names out, but they're in there. Can you give them a round of applause, please? My background's in television production, so I like to walk around when there's cameras, so that they have to practice pulling focus, you see. Who else should I thank? Oh, yes. No project can happen, no dissertation project can happen without the support of your dissertation supervisor. And, well, wait. And you have been blessed, I think, with some of the finest dissertation supervisors the computing department can offer. In fact, the only dissertation supervisors the computing project department can offer. But they've been brilliant, and I'm sure you want to thank them. Their names are listed in the programme. I will embarrass them later on. But you know who they are. Can you give your supervisors a round of applause, please? I'd like to thank myself for being so supportive of Femi. Basically, all I've done is he's come to me and said, look, I need a load of money to do this. And I've said no, and then he's complained, so I end up saying yes. And that's basically what's happened. I think we should also pay tribute to the catering today, because I was here when you had lunch, and some of you had a lot of lunch. So please thank the sandwich team. So I should also say thank you to Nonna for coming along this afternoon, and to Paul for supporting the project the whole day as well. But mainly, I think there's one person that we need to thank, who's really put all this together with the help of his committee, and the help of his team, and the help of the computing department. But without whom, none of us would be here today. Femi? I have forgotten our two keynote speakers, but have they both gone? They've left, yeah. Okay. In that case, there's a bottle of wine going to spare. Excellent. Okay. Finally, there's another group of people without whose efforts none of us would be here today, and that is you. Yeah. So give yourselves a round of applause. And the final thing I'd like to do is thank you. Thank you for representing yourselves and your university so brilliantly today. And I want to wish you, those of you that are departing from your studies, the very, very best of luck. I'm sure you're going to go far. Don't forget us. Stay in touch. Come back. We have another conference in February, and we would love to welcome you back, perhaps as employers, perhaps as freelancers, in whatever format. So please come back. Thank you very much. Enjoy your evening. Femi, you're on.
No, not yet. Hang on. Hey, guys, hey, yeah. Wait. Let's do one more thing. No. Look at, come on. Yeah. It is, guys, yeah. It is, it's so impossible for you to leave here without hearing from the course leader. We've got three course leaders, obviously, Prince, Martin, and Shaquille. Obviously, one of them has to say something, and one way or the other, you've all had the encounter with Shaquille, so Shaquille is going to make some comments, and he's going to have to say something. I won't let you go. No, come on. So, yeah, I'm going to invite Shaquille to say one or two words, and then I'll let you know about happy hour. After that, I'll let you know about happy hour, because we need to be happy, isn't it? Let's hear something from Shaquille, and then we discuss happy hour.
Good afternoon, everyone. Thank you very much for such a warm welcome. I've been asked to close the session. I've never done it before, and I don't know how to do it, but I'll do my best. If I make a mistake and I can't close a session, you would be stuck here until someone comes from the security team and kicks you out around midnight. But don't worry, I'll do my best. Yesterday I asked Siri how to close a session. And Siri gave me 4 methods of how to close a remote desktop session in Microsoft Windows. It was very helpful, isn't it? AI is still in its infancy. And that's why we are all here. Very soon, you will go out of this room, you will improve NLP, and you will teach Siri how to close a session. But before that, we have to close the session. Right, so that was a bit fun part. I would like to thank our honorable guests coming along from outside, our keynote speakers for delivering fabulous talk, organizers, FEMI for organizing such a nice event, senior management for inspiring and supporting and providing the resources. Food was very delicious. Thank you. And most importantly, you students. Without you, we could never have this event. So thank you very much. Thanks, everyone. Being a course leader of MSc Applied AI and Data Science, I would like to give a brief overview. And as Paul mentioned earlier, the course was started 2 years ago with an OFS bid of $500,000. The aim was to increase workforce and diversity in AI and data science. We started the first batch in September 21, and since then the course is expanding and growing. This year we received around 1,200 applications for this course, which is massive. The course will continue. The course will continue, but the scholarship program is going to come and end next year. However, OFS has launched the second phase of AI scholarships, which we would go for, and hopefully we will have more scholarships. As you all know, this is a conversion program, so it means many of you had never done any computing, computer science, programming, engineering before. And while looking at your work, your research, dissertation, when you were presenting here or outside the posters, I was recalling exactly 1 year back, exactly the same week when you started this course. And I remember very well, many of you were feeling a bit lost. Where we are, what have we started? But just in 1 year's time, you have been transformed into machine learning engineers, data scientists. Superb, fantastic. You are the future, and we are proud of you. So I also take this opportunity to congratulate you on completing this course. You are all passed, approximately. Yeah. No, I'm sure most of you, everyone passed, but I cannot disclose the result officially. You will hear the result very soon. So that's it from my side, and I now declare this conference is closed. Thank you very much. Thank you everyone who was involved.
The conference has been closed, but extra. You've all been asking me, yeah, Femi, won't we have some fun after the conference? We've done a lot. Happy hour. So the conference committee have managed to organize a discounted drinks and every other thing at Grumpy Monkey. That's 144 above bar. So if you want to join the conference committee, drink, enjoy. You've been wonderful. It's been a great 1 year. So I will expect you to go and enjoy yourself. And we'll see you some other time. Bye-bye.